Hello everybody, my name is Dave and this is my Python course for 2023 and beyond. Of course, I say that because we're heading into the new year and we're going to be on the latest version of Python, which is Python 3.11. So to get started, what you're going to want to do is simply download and install Python. So to do that, what you can do is come over to python.org, okay? And then you can simply hover over the Downloads tab, and then you'll be able to download Python 3.11. Now, if you are on Linux, I believe you're going to want to go over to other platforms, but you can see, depending on what operating system you're on, you could just click the tab over here on the left as well. Okay, so after you do that, now I already have Python installed, so I'm not going to do that. But after you install Python, what I want you to do is navigate to JetBrains, okay? JetBrains is a company, I believe a Czech company, that they create some of the best IDEs in the world. One of the best IDEs for Python is PyCharm, and it's quite popular. PyCharm is quite popular. So what is an IDE? It is an integrated development environment, and it's just software that allows us to write, well, helps us write code. And it usually has a lot of features, and it just makes our job as programmers or developers easier. Okay, so once you get to JetBrains, oh, and a little information about JetBrains that is pretty interesting is that they actually helped Google develop their official programming language, which is Kotlin, okay? Now, once you get to PyCharm, you're gonna want to download the Community Edition, okay? It's free and it's terrific. You know, if you're a professional, you know, if you wanna get the, you know, PyCharm Professional or something, I don't know. You can do whatever you want if you want the professional. It does come with a free 30-day trial, but the Community Edition has pretty much everything you need. So after you install PyCharm, and you can just pause this video. We're just going to hop right into the course. You can pause the video here, wait for PyCharm to fully install. After you do that, what you're going to do is you are going to create a new project. Now, your screen might look a little bit different because it's the first time you're opening it, but I'm going to create a new project, and this box will pop up for you, okay? And right up here is where you want to name your project. What I'm going to name my project is course, okay? And you can actually uncheck this box where it says create a main.py welcome script. It may or may not be checked, but just make sure it's unchecked. We don't need that, okay? So I'm going to go ahead and create. And we'll do this window. And there we go. We have our first PyCharm or Python project created. And what we're going to do is we're going to click on our top directory, okay? This is our main folder. And we're going to right-click this, and we're going to create our first Python file, all right? So hover over Python file. If you do happen to click on file, you can use this as well, but you have to use the .py extension. So this is just a little shortcut, just a new Python file right here. And what we'll do is we'll go ahead and name this variables and data types. Let me move this microphone a little bit, maybe a little bit over there. Okay, so let's call this variables. Actually, I'm going to type a little bit slow just to I don't want this course to go too fast, okay? So variables, and we'll just say data types. This is a little bit long. Make sure you have underscores, okay? You don't want to have empty spaces, and there's a reason for that. I'm not going to get into it right now. They work 90% of the time, but sometimes you can run into problems when you have spaces in the name of your file, okay? So let's go ahead and hit enter. And we have our first Python file, and what we're going to do is talk about data types and variables, of course. So let's go ahead by talking about variables. What is a variable? It is simply a container that stores data, okay? So let's go ahead and create one. We can name our variables whatever we want, but they should be appropriate and meaningful. So I'm going to name this variable name, okay? And then I'm going to put a space, put an equal sign, okay? And then I'm going to put another space. And I'm going to put a data type in here called a string. And a string is just a character or sequence of characters. To write a string, you actually have to use either single or double quotes. I like using double quotes. A lot of developers like to use single quotes because you don't have to hit the shift key. But I find that double quotes ends up saving me a little bit of time. And we'll get into that a little bit later, but I'm going to use double quotes for this course. So let's go ahead and put some double quotes here, and I'm just going to put any name in here, okay? So I'll just go ahead and put Dave. Sorry about that. Okay. And why don't we just go ahead and comment this, okay? So I'll put a space, pound sign or hashtag, another space, and then we can actually write a comment, okay? So why don't we go ahead and say something like, this is a string data type or character / sequence of characters. Okay. So a string data type, again, is a character or a sequence of characters. And it's being stored inside of this name variable. Remember, it's just a container, okay? So I could have a container like a sandwich bag, and what would I put in? Probably a sandwich. A container is like the same thing. Think of it as an empty box that you put stuff into, all right? So let's go ahead and create another variable. I'm just going to call this one x, okay? And I'm going to set it equal to 9, all right? Now, notice I'm not using double quotes here. This is a different data type. This is an integer, okay? So I'm going to do space, hashtag space, and say this is an integer, or, well, let's say integer data type, or whole number. Sorry. Okay. So we have our variable, which is x, okay, and it's equal to 9. Now, what is this variable? It's an empty container, and it's holding data. What kind of data? Well, it depends on the data type that you put in it. This data happens to be a string, which is characters or sequence of characters, and they have to be surrounded with double quotes, okay, or single quotes. An integer doesn't need those. It's just a whole number. Now, I will be a little bit repetitive in this course, so if you want to speed it up, that's okay. A lot of my students need repetition, so that's just how I teach. Now, there are probably other courses online where there's no repetition and you just whiz right through it, but I'm not going to teach that way. So let's go ahead and create another variable, and we'll set it equal to, let's do a 9.5, okay? So this is a float, or I will say data type again, or a number with a decimal point. Okay? So floats are like fractional numbers. They're numbers with decimal points in them, okay? And you have to make sure that you understand the difference. I mean, obviously it's pretty simple to and pretty clear what the difference is, but just make sure you understand the difference between the two, because it does matter in Python. Some other languages, it doesn't matter, like JavaScript. They're just all numbers, but in Python, it matters. Okay, now let's talk about the fourth data type, which is a Boolean. Okay, so what I'm going to do is create a variable called is_day, and I'm going to set that equal to true, because right now it is daytime where I am, so this is true. And let's go ahead and comment this. We'll say this is a Boolean data type, or let's do it, or true or false value. And we'll just put a slash in here instead, or true / false value. Okay. And let's go ahead and create another one. We'll just call this one is night. And of course, we're going to set this equal to false. Now make sure your Booleans have a capital. You can't use a lowercase t or a lowercase f. Booleans in Python have capitals. They're keywords, okay? And these are Booleans. They're true or false values. What do they do? Well, they're a little bit more complex. They're not super complex. They're a little bit more complex than I'm going to explain right now. But in their most basic form, they kind of direct code. For example, when something is true, Python will run code, and when something is false, Python will not run code, okay? So that's the most basic form of Booleans. Obviously, you can write your logic and change your logic up a little bit so that stuff runs when it's false, but we're not going to get into that right now. So, variables and data types, okay? A variable is a container, and the data type is what we're storing in that container. Now, you don't have to store a data type in a container, but if you don't, it's not very useful. For example, if I don't store all of my, Christmas tree ornaments in a box, or my holiday ornaments in a box if you don't celebrate Christmas, then it's not super useful. They're just kind of all over the place, or what I put each individual one in a different, it's just not very useful. So you usually want to use variables so you can take that data with you throughout your entire program. Okay. If you don't, you can't take it with you. It's not portable. Okay. All right. Let's go ahead and stop this lesson and just take a break, and then we will come back into the next lesson, and I will see you soon. Hello, everybody. We are back, and in the next lesson, we're going to go over something really, really simple. It's going to be like 30 seconds long, and it's called multiple assignment, and it's not always the best to use, okay? Sometimes it can reduce readability. We never really want to reduce readability. Perhaps if you have a very, very small program and it's only for yourself, fine, you can get away with it. But for the most part, we want to maintain readability, okay, or increase readability. So let's just call this multiple assignment, and let's get into it. And of course, I need to go ahead and get rid of that second A. Enter. And what is multiple assignment? Well, it's when we declare all our variables and put data types, store data types inside of those variables all on the same line. So just like we did in the last lesson, I'll say name x, comma, y, comma, is day, comma, and then is night. And now I'll put my equal sign, and then I'm going to assign corresponding values, okay? So I'll just go ahead and put Dave. I believe x was 9, y was 9.5. 0.5. And also, notice what I'm doing after each comma. I'm putting a space, comma, space. Now, the reason I'm doing this is to maintain styling. Okay, we want to maintain PEP 8. Okay, so basically, we maintain PEP 8 to maintain readability. Proper styling helps us maintain readability. Is day was, I believe, true because it's still daytime. And then we have false. Okay, so this is multiple assignment. It's when we do everything on one line. Sometimes you can use this. It's not a huge deal to use this, but I typically avoid it. It doesn't mean it can't ever be used. It just, in most instances, it can decrease readability. In some instances, it's completely fine. All right, so that was the end of that lesson. Very short. I will see you in the next lesson. Okay, everybody, I'm back and I'm ready for the next lesson. I hope you are too. So let us begin. Again, when we create a file, we're going to want to create it in this top directory, okay? So I noticed that I had multiple assignment. I must have misclicked something. It was not in the proper folder. So make sure you click up here, okay, on the top directory, and then create your Python file there. What we're going to do is we're going to name this string methods, okay? And let us begin. So string methods. Well, a string is a data type. And because it's a data type, it's also an object. Don't think too much about this, okay? I know that seems, a little bit crazy. Like, oh, it's a string data type, it's a string object. Like, what is it? Well, it's both, okay? But we're not going to get into objects right now. I don't want you to, get intimidated by that. It is a string data type, therefore it is a string object, therefore it has behaviors, okay? What do we call those behaviors? We call them methods, all right? So let's go ahead and create a string data type. We'll say name again. Actually, let's do city. And we'll just put Boston, okay? Okay, again, I have a string data type, which is also a string object, and therefore it has behaviors. What do we call those behaviors? Methods. How do we access those behaviors? Well, we type the name of the variable generally. We can access them a couple different ways, but generally what we'll do is we'll type the name of our variable. City represents Boston. And then I'm going to use the dot operator. Okay, and there we have it. You can see all of the methods. And if you look over to the left, you're going to see these little pink circles with M's in it. And that's just PyCharm's way of telling you, hey, these are all the methods associated with a string data type which is also a string object, okay? So let's go ahead and just kind of look through these. Why don't we start off with an upper, okay? So you can always tab to autocomplete. If you notice that one, I just typed that in really fast. I didn't actually type it. I hit tab. The second you see the method that you want at the very top, you can go ahead and hit tab and it will autocomplete it for you. Okay? Now, what you're noticing is I wrote the name, so I basically called the name of the variable that I wanted to use. I used the dot operator, and then I accessed the upper method. Now, what are these parentheses? These parentheses are the call, okay? They tell the method to occur, okay? And if you don't have these, it'll simply tell you where the method is stored in memory. But once you add the parentheses, then it will actually call the method and perform that behavior. What do we put inside of these parentheses? Well, in this particular method, we don't put anything in it, okay? But in many methods, we're going to actually pass in what are called arguments. We'll approach those in a minute. So let's go ahead and run this. And what we can do is actually right-click. And then you're going to see run string methods, okay? Now, the reason I'm telling you to do this is because we haven't run this file before. If you have not run a file before, you really should just right-click it. Or you can Control-Shift F10. But I just like to right-click for the first time. And then subsequent, when I run the file afterwards, because it's already been run and it's already been selected up here, you can just hit Shift F10. All right, so I'm running this. And we see nothing. Why do we see nothing? Well, because we haven't told Python to display anything. And to do that, we use what's called a function, okay? And specifically, we're going to use the print function. So let's go ahead to the beginning, and we're gonna type print, and then I'm going to put a parenthesis and another parenthesis. Okay, so now, what did I pass into this function as an argument? I passed in city.upper. Okay, I'm not going to pass an argument into the .upper method, though, because it doesn't require one. Now, if I run this, you can see this particular behavior makes every letter uppercase. Okay, so let's go ahead and move on. Okay, let's go ahead and print a city dot. Let's do a dot title, and let's run this. Now you can just Shift F10. It's going to run. If you're on Mac, I think it's Command R, but I'm not sure. I don't have a ton of students on Mac. Actually, most of my students are on Windows, so I don't remember the Mac shortcuts. Anyways, you can see that dot title actually creates uppercase. Now you may be wondering, well, why didn't you just put an uppercase up here? I actually like to use all lowercase. The reason I like to use all lowercase is it just keeps everything uniform. Uppercase and lowercase have different values. They're two different things. And if I keep everything uniform via lowercase, I just do everything lowercase, it's easier for me to find data when I need to, okay? I don't have to worry about, oh, was it an uppercase? Am I going to find an uppercase? No, I know everything that I do is lowercase, and when I want to make it presentable, I use methods instead, okay? All right, so we can see that the dot title method, again, capitalizes just the first character, but what I'm going to do is I'm going to put an MA in here too. And now let's run it, and you can see that the dot title method doesn't just capitalize the first character, it also, after every space, characterizes the first character. Capitalizes the first character after every single space. Let's go ahead and run another method. So we'll do a print a city dot, let's do a dot capitalize so you can see the difference. And you can see that this particular behavior capitalizes only the first character, all right? And it's different than dot title. It doesn't do it to the characters after any spaces. Okay. All right. Let's go ahead and move on. Let's go ahead and print a city dot. What do we want to do here? Let's go ahead and look through a little bit. Why don't we do an is digit? This one's cool. And let's run this. and we get false. Why do we get false? Well, Python comes up into this string and it says, hey, are you a digit string? It checks, is this a digit string? Well, there's no digits in here, okay? So we know it's not a digit string. What if I put a 9? Okay, will that make it a digit string? Let's run this. And it still doesn't. A digit string has only digits in it, okay? So that's why we're getting false. Let's go ahead and move on. Let's go ahead and print a city dot, let's do a city dot find, okay? And I'm going to pass in an argument for this one because we have to tell Python what to find. We have to tell this method what to find. And this actually takes a string as an argument. So I'm going to have to put in my quotations, okay? And I want it to find O. Let's go ahead and run this. And I get a 1. What is that? What is a 1? Well, it's representing the position or the location. And we do that by using an index, okay? So with indexes, we start from 0. So that means the location of B is at the 0 index, and the location of O is at the 1 index, S 2, T 3, the second O 4, and also remember that space has value, okay? So I believe that would be at the 6th index. Now, you may be wondering, well, why is it only giving you a 1? There's 2 O's in here. Unfortunately, the dot find method only finds the first instance, okay? So that's why it's giving you a 1 and not the 4, okay? Now, let's go ahead and move on. So let's go ahead and print a city dot count. And let's go ahead and count the O. Let's run this. Now, what this particular behavior or method does is pretty simple. I'm sure you've already figured it out by now, but it just counts how many occurrences there are, okay? So there are 2 occurrences of O. It's counting that, and it's returning a number to you. Now, what is this data type that it's returning to you? Because that's important. Is it returning a 2 in string form? No, it's returning an integer to us, okay? And we'll get into that a little bit later. But as you can tell, these required arguments, these behaviors, again, these methods, they did not require arguments. So when will you know whether something requires an argument? You have to pass in an argument. Well, typically it just comes from experience, but you can always get information. And I'm going to show you right now what you could do. So for me, what I like to do is I like to call that particular method. Let's just say I wanted to do, let's do is lower, okay? Now, typically what you can do is click inside of these 2 parentheses and just hover right over it. And you can see we get this box here. And this is telling us, this is called a document string. Oops, sorry about that. This is called the document string, and it gives you more information. So return true if the string is a lowercase string, false otherwise, all right? And you can see that it also is going to return a bool or a boolean, which is a true or false value, remember. And you can tell by this little arrow here. Also, what you can do is you can click on the documents here. So let's go ahead and do that. And what I want you to do is learn how to read documentation, okay? Because it's crucial. You need to be able to read documentation. All right. And you can see return true if all case characters in the string are lowercase. So the documentation is also very useful. And you can see that this requires no arguments. Nowhere in this documentation or in that document string did they say this requires an argument, all right? Again, most of it just comes from experience, but you can always figure out whether or not it requires an argument. Let's go ahead and print a city.replace. And let's go ahead and replace the O, okay? Now, this requires 2 arguments. So this is my first argument, and now I'm going to put a comma, remember a space after every comma, and I have to tell it what to replace the O with. And let's just replace it with an I, okay? Let's run this, and what does it return to us? A Biston mass, okay? Now, this also allows you to enter an optional argument, okay? So you can specify how many i's you want or o's you want to replace. Perhaps you only want to do the first o. You actually could just put a 1 here. Let's run it. And you can see it only replaces the first o. You can also, say this had like 15 o's in it. You could replace the first 5 by just putting a 5 here. Again, this is optional, so you don't have to use it, all right? Let's go ahead and move on. Let's go ahead and print a city dot, and let's just try to find something. What do we want to do here? Also, by the way, I don't know if I told you, the is lower method is just checking to see if this is lowercase. Let's do a, well, how about we end it here? We'll end it here. Now, just one thing to note. If you start seeing these dunder methods, you've gone too far. What are dunder methods? Double underscore methods. Don't worry about them right now. You've gone too far. You're typically just going to use these regular methods up here, okay? All right, so I'm going to delete this. And just to recap the lesson, a string data type is also a string object, and objects have methods, okay? Those methods just represent the behaviors. Every data type has behaviors or methods, okay? So an integer data type is an integer object and it has integer methods. A float data type is a float object and therefore it has float methods, okay? So the reason we're going over string methods is because they're much more useful, okay? Boolean, float, integer methods are just not that useful, okay? So that will wrap up the lesson and I will see you in the next one. Hello, everybody. We are going to start our next lesson. And to do that, we're going to, again, right-click our top directory here, hover over New, create a new Python file, and let's go ahead and call this typecasting, okay? What is typecasting? Very simple. We don't want to overthink this. Typecasting is when we take one data type and cast it into another one or change it into another data type, okay? But it does have to make sense, okay? Python just doesn't just change whatever you tell it to change, okay? You have to do things logically, all right? So let's start off by creating a variable called x, and let's store a string 9 inside of it. Let's create another variable, let's call it y, and let's store an integer inside of it. And let's create another variable. We'll call it z. And let's just go ahead and put a float inside of it. So these are all the same number, okay? But they're all different data types. Perhaps we needed to perform some kind of mathematical operation. Well, do you think that I could perform math on a string? I actually can, but it's different math, okay? It's not the math that we know. We'll get into that a little bit later. But basically, I can't do any kind of arithmetic on a string, all right? So I may need to change it. I may need to convert that 9. And to do that, what I'm going to do is just reassign. So I'm going to say x equals, now I'm reassigning because x already exists. And I'm going to say x equals int 9. Sorry, not int 9, int x. Okay, so x now equals whatever x was, but the integer version of it. Okay, so let's go ahead and print this. Okay, so let's print x and let's run it. Oh, and again, because this is a new file, you'll want to right click and then run. Okay, and now we have this 9 here. All right, but how can we tell that it's been converted to an integer? Well, obviously we had no errors. Like, we know this has been converted into an integer. But we can always ask Python. We can say, hey, Python, print the data type of x. And we do that by using the type function. And then what comes after a function? Parentheses. And what do you pass into parentheses? Arguments. Okay, so let's go ahead and run this. And you can see it is an integer object of the integer class. Okay, what it's telling us is this is an integer. Okay, now let's go ahead and move on. Let's try to convert 9, integer 9, so y equals str9. Not 9. I keep doing that. Sorry. stry. And let's go ahead and run this. We have no error. How can we see what data type it is? Well, we can always just say print type y. And let's go ahead and run this. And you can see Python is telling us, hey, that is a string. So our typecast on line 8 did indeed work. All right. Let's go ahead and typecast z. So we have a float. Why don't we try to convert this float into an integer? And let's see what happens. So z now equals int z. And let's run this. Okay. And let me go ahead and... Actually, because we're on Python 3.11, let's just go ahead and print z. And we get a 9. I actually don't think this was possible in Python 3.10. I may be wrong, but typically you'd get an error because there's a decimal point. I do believe this may be a new feature. I could be wrong. If I'm wrong, just put that in the comment down below and let me know. But I'm pretty sure we were never able to typecast that. So, hey, great. Let's go ahead and move on. Now, what I want to do is convert. Let's go ahead and create another variable. Let's just call this xyz. Okay, and let's set this equal to 19. I want to convert 19 to a Boolean. Okay, so I know that sounds a little bit weird, but let's just say xyz now equals bool xyz. And let's just go ahead and print this. Oops, xyz. And what do we get? True. So what's going on here? How did you just typecast a number into a true or false value? Pretty simple. And actually, it's very useful. But any number that is not 0 is true. And you may be wondering, well, why? Well, because it can be very useful to us. Okay, so perhaps we have a program that depends on how many people are voting. And as soon as we have 30 people voting, and as soon as that number reaches 0, we want the program to shut off. Okay, so maybe the program is true when there's 30 people. 15 people vote, there's 15 people left, the program is still true. Another 15 people vote, the number becomes 0. And then it becomes false and the program no longer runs. Okay, so it can just be very useful for us. And it's the same thing with strings. Okay, so let's create a string and I'll just say name equals Dave. And let's just go ahead and convert Dave. So we'll say name equals bool name. Let's print name, run it, and we get true again. Well, the reason it's true is because this has value. The only time a string has no value is when it's empty. And that applies to some other data types as well that we'll get into. But because this is not empty, it is true. Now if I make this empty and run this, it becomes false. Now, what happens if I just have a space in here? This is still empty, right? Well, let's run it. And I get true. Space has value. Remember that. Space has value. Okay, now this is typecasting, and you're going to see in the next lesson why this is very important. So what we'll do is we'll end the lesson here, and I will see you in the next. Hello everybody, I am back. I hope you are ready for the next lesson. I took a nice little nappy poo, and I am rested up and ready to go. So what we want to do is create another file. So we're going to click on our top directory here. And let's just call this input, okay? Now, taking input is super useful. We may need information or data or something from a user, okay? And the way we do that is by taking input. So how do we take input? Very simple. It's just like print, okay? We call the name of the function, which is input. You can tab it if you want. Remember, parentheses after functions and methods. And we have our parentheses here, and now we're going to pass in an argument here. What kind of argument do we pass? A string, and it will be the prompt. It's going to tell the user what kind of information we want from them. So I'm just going to ask somebody for their name. So I'll say, please enter your name. And what I like to do is put a colon here and a space. Okay, let's do it without that. Let's go ahead and run this program. Remember to right click if it's because it's a new file. And you can see down here it's asking me and it's allowing me to put input in. But you can see this cursor is just blinking right next to the E. And a lot of people have a tendency to put a space and then enter their information. So, Dave, remember, space has value. This can actually break the program. Okay, this little space can break the program. Never allow the user to have the opportunity to put that space in there. And the way we do that is by coming up here, and I'd like to put a colon and a space. Now let's rerun this. Stop and rerun. And now this looks a lot cleaner, okay? And now the user is not going to go ahead and try to put a space to give themselves space. Trust me, it happens a lot. And let's just go ahead and enter a name. So I'll go ahead and enter my name, hit enter, and everything worked, but this program does nothing. Remember, variables. We want to use variables. That makes our data portable. So if I want to use that name, I would store it in a variable. Remember, you can name your variables whatever you want, but they should be appropriate and meaningful. I'm not going to store this in a variable called, FARC. What does FARC mean? That it's not useful. It's not meaningful at all. So we'll just go ahead and call it name. And now what I want to do is when I take somebody's name, I want to go ahead and print like a greeting. So I'm going to say, hello. Then I'm going to put a plus sign here, okay? And then I'm going to put name. Let's go ahead and run this. Let's just go ahead and put Dave here. And we have hello, Dave. Of course, we're missing the space, the appropriate space. So I could come right up here and I could add that space. Let's run it again. I know I'm repetitive, I'm redundant, but repetition is what gets us really, really good at coding. All right. So I'm going to put my name again and it looks better. But we're kind of doing something that I don't like to do anymore. In fact, I hardly ever do it. I mean, I still do it, but I don't do it that often. And that's called concatenation. See this plus sign? Well, we take input as a string. When somebody gives us input, it comes in as a string. They can write 9, 10, 11. We know those are numbers, but they come in as string numbers. Remember in typecasting, this was a string 9. If they put a 9 in this input, well, it would come in as a string. So when I have a plus sign and I have a string and another string, it's called concatenation, and it concatenates them together, okay? Generally, what will happen is they'll go from 2 memory locations to 1, all right? Now, this print statement is simply printing it. One thing I want to discuss with you is print has no value. We'll go over that a little bit later, but just remember that moving forward. Print has no value. It simply displays stuff, and that is it. Okay, so how do we do this without concatenation? We're going to use what's called an F string, okay? I want you to use these as much as possible. They're amazing. They're my favorite. We're going to use them the rest of the course as much as possible. Sometimes you have to use concatenation. Anyways, we have this F string, and what we'll write here is our message. So we'll say hello. And then what we do is we use curly brackets. These curly brackets allow us to put in it allows us to put in code, Python, logic. So I'm going to just simply put the variable name here. And let's run this. I'll put in my name, and we get hello, Dave. Okay, so let's go ahead and make this a little bit more complicated. I don't want somebody to enter their name. I want somebody to enter their dog's name. So please enter your, let's just say dog. Dog's name. Now, this brings me to why we use double quotes. Well, why I like to use double quotes. Because I have this single quote here, it would actually interfere with my single quotes out here had I used them. So you would have had to fix that by either using what's called an escape sequence or escape character, or use double quotes. I like to use double quotes. It just makes things easier for me. Again, this would interfere with those single quotes that you used outside. All right, so we're going to ask them to enter their dog's name. And now I'm going to ask them to enter their dog's age. Okay, so I'm going to say, please enter your dog's age. Remember, colon and space. And what I'm going to do is change this F string. I'm going to do something like this. I'm going to say name the dog is age years old. Let's go ahead and put a exclamation point there and let's run this. So now we're taking two inputs and we're storing them in two different variables. And I'm just going to put Spike, and the dog's age is, let's just say the dog is 7, okay? And we get Spike, the dog is 7 years old. But perhaps we wanted to present the dog's age in dog years. Well, we know, I don't know if it's scientifically proven, but I think it's universally accepted that dogs age by 7 years for every 1 human year. So what we could do is multiply age by 7. And this is the beauty of an F string. It allows us to add Python code and Python logic into our strings. And the output ends up being a string, okay? So let's do age times 7. And let's go ahead and run this. So let's put Spike, let's put 7, and look what we get. A little bit strange. Remember, in one of the earlier lessons, I forget which one, but I said, well, we can do math with strings, but it's not the math that you and I know. It's not arithmetic, okay? This is string math. It's weird math. And all it's doing is taking the string 7 and it's multiplying it 7 times. So how do we fix that? Well, we can use typecasting. Remember, what I would do is wrap the variable. Okay, so let's go ahead and run this. Spike 7, and it works. However, there's a little bit of a problem here. This works, it's fine, but every time I want to convert age, I would have to actually wrap it. I'd have to typecast it every single time, unless I typecast the source. Where's the source? Right up here. Now, whenever I use it, it will remain an integer. Okay, so let's run this. Spike 7 works perfectly, and we did this the right way by typecasting the source. Now, sometimes you may not want to typecast the source, but typically it's a much better approach. All right, let's go ahead and create a area calculator. Okay, so what I'm going to do is I'm going to highlight all of this, and I'm going to teach you something. Control /. This has now been commented out. Python does not, it ignores comments, okay? The interpreter, it ignores comments. So it sees the hashtag, it ignores it, it's not considered code. Let's go ahead and create that area calculator. And we need two things to calculate area: length and width. So let's go ahead and do that. Length equals input, and let's just go ahead and ask them. So we'll just say, please enter the length of the object, colon, space. And what I actually like to do, and this is a feature of PyCharm, is I like to hit Control D, and it will duplicate code for me, okay? Because the only thing I'm going to change here is width, and then right here, width. All right. Now that I have the length and the width, what I can do is I can create another variable. I could say area equals length times width. All right. And why don't we just go ahead and print something so the user can see their area. So we would say something like this: the area of your object is curly's area. Let's go ahead and run this program. Okay, so let's just go ahead and put a 15 here, and let's put a 78 here. Okay, so we get an error, here. I want you to try to figure this error out. I'm going to go ahead and give you a second. Okay, so pause the video and try to figure it out. All right, so what's going on here is we're not typecasting. Now, typically you would want to typecast this as a float, but as we learned, I believe Python 11 actually will still typecast floats into an integer now, which is strange. But actually, let's just go ahead and typecast this into a float. And same with this one, okay? Let's go ahead and run it again. And we'll put a 56.9 and a 23.76. Okay? And there is the object of our, as the area of our object. Now, you notice it's not in feet or inches or anything like that. This is just kind of like a broad area. They can enter whatever they want in here. Okay? So that is taking input. We will wrap the lesson up here, take a little break, and I will see you in the next lesson. Okay, everybody. I hope you're ready for the next lesson. Let's go ahead and get into it. So what we're going to do is create a new file. Again, top directory, click on Python file. Let's just go ahead and name this one math module, okay? Now, this is less about the math module and more about learning how to use modules, okay? Now, this particular module is part of the base standard library. That means it comes with Python, all right? So typically, if something doesn't come with Python, you'll want to come to the terminal here. Now, if your terminal says PowerShell, what I actually recommend doing is clicking this down arrow, okay, going to settings, and then shell path. What I would do is switch it from PowerShell to command, okay? I don't really like using PowerShell. In fact, I think PowerShell is horrible. I'm much more of a bash kind of person, okay? So let's go ahead and click OK. And then what you would want to do is exit out of the terminal that you're in and then just open it back up. And from now on, it will only open up the command prompt, okay? Now, if it's not part of the base standard library, you're going to have to run a pip install, okay? This is the Python package installer. We're not going to do it. And then you'd put the name of the module or the package that you're trying to install. But we're not going to do that right now. We're just going to work on the math module. So again, this comes standard in the library. So what we're going to do is just simply import math. Now, how do we use the module? First, before we get into that, you're going to notice this is gray. That's PyCharm's way of telling you, hey, you've imported a module and you're not using it. And that is a waste of resources in Python, because Python will run this entire module first. It sees line 1, it says, oh, you're importing math. I'm going to completely run math. And then it runs your script, okay? So basically, we don't want to import stuff if we're not going to use it. Now, if I was to right click on math and click go to and declaration or usages, let's just scroll down. You can see it's going to run 470 lines of code unnecessarily because, again, we're not using it. So how do we use it? Well, we simply type the name of the module. Then we use the dot operator. Again, this is much like calling a method or accessing a method, but there's a difference here, okay? These are functions. We're typing the name of the module, not a variable, and then we're accessing its functions or its variables, okay? Now, let's go ahead and do a math.ceil, okay? And let's just go ahead and put a 9.1 here. And let's run this. And remember to right click if it's your first time with this module open. So you'd right click and run it. And we can see that there's nothing here. Remember, we have to use the print function to see stuff. If we want Python to display stuff, we must use the print function. Okay? I purposely will leave the print function out just so I can repetitively tell you about it. Okay? So, because again, repetition is what makes us good. Let's go ahead and run this now, and you can see we see it. So if math.ceil rounds up to the nearest whole number, what do you think rounds down to the nearest whole number? What is a whole number? It's an integer in Python. So if you guessed it, congratulations, it is math.floor. So let's just go ahead and put a 9.9 in here. Let's run it. I ran the debugger. Sometimes, I believe if you hit Shift F9, it runs the debugger. So make sure you hit Shift F10, okay? Again, rounds down to the nearest whole number or the nearest integer. Now, I want to tell you about math.pow. Now, this comes with Python now. You do not need to import the math module to use pow, all right? But we're going to go over it anyways. So math.pow, this is exponential math. Let's do 5 to the power of 9. Again, this takes 2 arguments, so how do you separate those arguments? With a comma, okay? What comes after a comma? A space. That's proper styling. Let's go ahead and run this. Exponential math is always huge, so we get some astronomically large number. Let's go ahead and move on. Okay, so let's go ahead and print a math dot square root, okay? And let's go ahead and do, let's say, 45. Okay, so we get the square root of 45. Pretty simple. This is how we use modules. Now, one thing I just want to show you is nested functions. Now, we already have a nested function right in front of us, but we're going to make it a little bit more complex. So I want to print a math dot square root. I want the square root of math dot pow, 6 to the power of 7. And actually, why don't we say 6 to the power of math.pi? Now, you may be wondering, well, why do you not have parentheses after math.pi? Isn't that a function? No, it is not. It's simply a variable inside of the math module. Actually, put a dot and a p here. You can see it's got that little orangey circle with the v. It is a variable inside the math module that simply holds pi, 3.14, okay? So let's go to pi. Let's go ahead and run this. And that's a nested function. Now, the reason I wanted to show you this is because, you know, you will use nested functions, and it's nice to just kind of get used to them. This is how Python works. But also, because I want you to know that the innermost function works first. What's our innermost function? Math.pow. So this function is going to work first. It's going to return a value. Then we're going to get the square root, okay? We're going to get the square root of whatever value this function produced. And then we're going to print it, okay? That's our very last function. All right, so this is just a simple import. Let's talk about using an alias, okay? Now, math. It's pretty simple. Sometimes our modules have like longer names, but sometimes for a shortcut, we can use what's called an alias, and we would just use as m. Now, you can see that these are all underlined with red squigglies, all right? That's because math no longer exists. It's been renamed. We're using an alias. It's m now. So I'm going to use a little keyboard magic first. So I'm going to double tap control, and then I'm going to use the down key. Double tap. There we go. And I'm going to delete. Now, because it's renamed as m, it's m.seal, m.floor, m.pow. So the alias can be useful, okay? That just saved us, 12 characters, okay? So, yeah, 12 characters. Now, you're like, well, that keyboard magic didn't work down here. No, it didn't. So I'm going to show you another thing that's really useful. What we can do is hit Control-R. This brings up our replace menu. And what I can do is type in math dot. And I want to replace all math dots with an m dot. And I'm going to click Replace All. Much faster, okay? Now, again, this is using an alias. If we run this, let's hit Run, and everything is working the same, okay? So an alias can be very useful. A lot of developers use it. You don't have to, but I like using them. Sometimes I don't. I'm going to show you another way to import that is not necessarily the best way to do things, okay? In my opinion, it reduces readability, and it's harder to debug, okay? So let's go ahead and change this import statement to from math import. And let's just go ahead and import. Then we name the function we want to import or the functions. So I'm just going to say seal. Okay. Now the only function that I have that's going to work is seal. So if I was to delete this, seal is going to work. What about floor? Floor doesn't work. I didn't import it. I can put a comma here and I could say floor. And now floor will work. This is not a good way to do things, okay? The reason is because if you have a very large program and say, you want to debug it, or perhaps another developer is trying to debug it, they're going to have a hard time finding every instance in which you used math. Whereas like before, they could probably hit Control F and they could say, oh, he's using the math module. Let me go find every instance. And this is going to show them every instance in which you used math. Or in this case, we used, remember, M. So I could just say M dot. Now, every instance where you use M, that's going to come up. Your developer is going to be able to find it. If you use this from math import, you don't have that feature, okay? So let me go ahead and delete that. And now I just want to quickly show you, you can actually import every single function with the asterisk, all right? And now I would just hit Control R, and every time I see an M dot, let's replace it with nothing, okay? So replace all. And this works too. The only function in here that would work regardless is POW, and that's because it's been moved over into actually being a part of Python. So let me go ahead and delete that. And again, this is not something, you do not want to do it this way, okay? So what I would do is, actually we can't even fix it now with the replace method. But yeah, I would typically avoid this unless you have like a really, like a really small script. Now, one question that I get a lot is, hey, if you import a specific function, are you saving resources? And the answer is no, it still runs the entire script. So why even use it? Don't use it, okay? All right, so that actually will wrap up the lesson. That's how you use modules. Again, if it's part of the base standard library, you can just import it. If not, terminal, and you got to run a pip, okay? Pip install. I believe there's another way to do it in PyCharm, where you can go to File, Settings. Actually, I don't know where it is. Maybe it's down here. I'm not sure where it is. Actually, I'll find out where it is, and then I'll show you another way where you can actually install with PyCharm. But I never use it. I always use pip, okay? All right, so I will see you guys in the next lesson. Hello, everybody. I hope you are ready for the next lesson, so let's begin. Now, again, we're going to right-click, new Python file, and let's go ahead and call this arithmetic operators. This will be a quick lesson. Okay, so what are arithmetic operators? Let me first off clean this up a little bit, get rid of some of these tabs. And I also want to clean this up. I have two programs running. You can see right here, this will actually show you which programs are running, and you can just click the X and you can terminate those programs. Okay, so you know the main arithmetic operators, okay? I'm sure you do. It's going to be the plus sign, the minus sign, the multiplication sign is the asterisk. And how do we do division? Well, simple, /, okay? So let me go ahead and let me comment these. So I'll say addition, just do subtraction, multiplication, and division, okay? Now, the reason I'm showing you this is because I want to show you modulus, exponential math, and floor division. It's not about these, okay? So how do we do floor division? Well, floor division is pretty simple. It just rounds down. So if I was to say print 9, let's just do like 900 divided by 32. And let's run this. Again, right click, and we get 28.125, all right? Now, if I was to do floor division, what it will do is actually round that down. Okay, so let's run this again, and it rounds it down to the nearest whole number, which is an integer. Okay, so floor division can be super useful. Now let's talk about modulus, and I love modulus, so let's just go ahead and do 900 modulus 32. Okay, let's run this, and what does it do? It divides 900 by 32, and then it gives us the remainder. Okay. So modulus is super useful for finding like even numbers, odd numbers, or multiples of a particular number. Okay, so I could see if something is a multiple of a particular number if this equals 0. So let's just go ahead and put, say, 33. See what we get. Okay, it's got a remainder of 9. Let's do 34. Oh, geez, sorry about that. 34. Let's run it. Remainder of 16, 35. Remainder of 25. So you can see it's just giving us the remainder. I don't know all of the multiples of 900. So I don't know if we're going to find 0. Let's try 36. Let's do one more. 0. Okay, so 36 is a multiple of 900. Again, modulus is very useful for finding multiples, evens, odd numbers. Okay. Now let's quickly address exponential math. Now, before in the math module, we were using the POW function. Okay. Why? Who cares? Just use 2 asterisks. That's what I like to do. Now, you could make the argument that POW is more readable because most people understand that as power, okay, which represents exponential math. But I just like to use 2 asterisks. Okay? Very simple, short lesson. I will see you in the next one. Hello, everybody. I hope you're ready for the next lesson. So let's begin. Let's start off by creating a new file again, and we'll call this conditionals. Okay. Oh, forgot the D. Let's go ahead and rename that. Now, anytime you change a file, it's actually called a refactor. Okay. So if you do anything, you make changes, that is a refactor. All right. Now, what are conditionals? Well, basically, conditionals allow us to execute a block of code if a certain condition is met. Okay, so let's go ahead and create a variable called age, and let's set it equal to input. And I want to typecast that to an integer. And let's just say, please enter your age. Okay, so what I'm going to do is I'm going to evaluate this age. And what I'm going to start off with is an if statement. So I'm going to say if age is greater than or equal to 21. We're going to go ahead and print a message. Now, notice what I'm doing. I'm putting a colon at the end of my condition. This is my condition. This is my if statement. And then I'm tabbed over. Anything that's tabbed over will execute if the condition above it, well, it will execute if the condition above it ends up being met or is true. So let's go ahead and print, you are legal to drink. Okay, so let's run this program. Let's right click, run it, and let's just go ahead and put 23. Okay, so our program is working perfectly. But what about anybody who's not greater than or equal to 21? Let's run this program and just put like 19 here. Nothing executes, okay? If you want to execute something for anyone who's not greater than or equal to 21, well, then you have to use an else statement. So we say else, and then we don't put a condition, okay? There's no reason to have a condition for anything else. For example, if I'm in my garage and I have a bunch of paint, and the only paint that I care about is the red paint, well, I may say, move the red paint all the way to the right, and everything else can stay put. I don't need to have a condition, okay? I don't care what color paint. If it's not red, it's staying where it is, okay? So, again, we enter down, we're tabbed over, and let's just go ahead and print, you are not legal to drink. And let's go ahead and run this now. So if I put a 19 here, you can see that this condition is not met, therefore it's false. And then this condition is going to execute no matter what, okay? Because there are no conditions. If the condition above it is not met, it's going to execute. Now, perhaps we had another condition. Well, we can use an elif, okay? Elif is short for else if. All right, so when you see elif, I want you to think of the words otherwise if. And if you see the else statement, I want you to think of the words everything else. Now, elif statements have conditions. So I'm going to say elif age is greater than, say, 95. Let's go ahead and print, you are far too old to be drinking. Okay, Control Z. And let's go ahead and run this. And I'm going to put 96 here. What's going on? This is not working. Well, what's happening is this condition is not structured properly, okay? What I like to do is put conditions in either ascending or descending order, or I like to put extreme conditions at the top, Okay, now you could classify this as an extreme condition, but I'm just going to go with descending order. So I'm going to cut that out with Control X. I'm going to paste it up here, and we see that we have an error. We have red squigglies here. Now, the reason is because you have to start with an if. Okay, so you have to have the if statement, and now this will become an elif. Now let's run this. Let's go ahead and put, let's get rid of that box too. Let's go ahead and put a 96. Everything's working. Let's just double check by putting, say, a 20. Let's just go ahead and put a 95, okay? Because this is greater than. It's not greater than or equal to. So this should trigger that you are legal to drink. And it does. One thing you don't want these blank spaces in between your conditions. All right, so again, we want to structure in ascending or descending order or put extreme conditions at the top. Remember, the first condition must be an if statement. What's happening is Python will see this. If this is true, it will execute and it will shut both of these conditions off, okay? If Python sees this and it's false, what it will do is it'll evaluate the next condition. If that's true, it'll shut everything else off, all right? So that's how conditionals work. Now, we can have as many elifs as we want. Remember, elifs are else if statements, and I want you to think of the words otherwise if. So let's say something like this. Otherwise if age is greater than, actually let's do less than 19, okay? Let's put a colon there, and let's just go ahead and print, and we'll say you're not there, let's say just yet. Okay, so let's go ahead and run this program now. Let's shift F10. Let's just go ahead and put 18. And we can see you're not there just yet. All right. So again, we can have as many elif statements as we want, but we should always try to structure these in like I said, ascending, descending order, or extreme conditions at the top. All right. So what if you had more than one condition, but you wanted it on the same line? So you could do an and statement. You could write an and statement. You could say, and age is greater than 16. Okay. Now, what you're seeing here is yellow squigglies. Okay. There's another way to write this. And believe it or not, for a lot of my students, I like to tell them to just write it like this because it's really clear and easy to read. But you could simplify this. Okay. There's a chain comparison that we can use. So let's go ahead and simplify chain comparison. And you can see this does the exact same thing. All right. So you can use either one. I actually think the other one's more readable. And I like to emphasize readability when it comes to programming. To me, readability is crucial. If your code is readable, well then in 10, 20 years from now, people will still be able to use it. It's just readable. You know, developers can work on it forever. If it's not readable, you know, you're going to have issues, okay? It's not going to stand the test of time, in my opinion. So readability. Okay, so you can see we have two conditions here. Let's go ahead and run this. And let's put 18. And it's still working, but let's go ahead and put 15. And you can see you are not legal to drink. Okay, so these are how conditionals work. Let's go ahead and comment these out, and let's do one more, okay? Let's go ahead. Remember to comment out. You can highlight what you want to comment out and Control /. Okay, so let's go ahead and use conditionals for the area calculator again. Let's go ahead and ask somebody for the length of their object, and we'll say length equals float input, and we'll say what is the we'll say the length of your object. Okay, and I'm just going to hit Control D, and we'll change this to width. Okay, we'll say width here. Let's go ahead and create that variable for area. So we'll say area equals, I'm getting a little bit tired, so I'll probably wrap it up after this lesson. And area will equal length times width. Okay. All right. So we have the area, and now what we're going to do is ask the person for the area of their room. So we'll just create another variable called room area. We'll set it equal to input. And what we'll do is we'll just ask them for the area of the room. So please enter the area of your room. Okay, and now what we're going to do is just compare the two, okay? If the area of the object is too big, we're going to say, hey, this will not fit in your room. And everything else will fit in the room. Remember, everything else, we use the else statement. So I'm going to say, if area greater than room area, well, then we'll simply print this will not fit into your room. And everything else will. So we'll just go ahead and print this will fit into your room. Okay, so we basically did the same thing up here, except we're really analyzing two variables which happen to be input, all right? Well, really three, but we pretty much changed these two inputs into one variable, okay? So we're comparing area against room area, and we're using conditions to evaluate whether or not an object will fit in the room. All right, so this will wrap up the lesson. I hope you enjoyed it, and I will see you in the next lesson. Hello, everybody. I hope you're ready for the next lesson, and let us begin. So, of course, as usual, we'll go up to our top directory, and let's just go ahead and create a file called while loops, okay? We will be going over while loops in this lesson. Now, what is a while loop? It basically allows us to execute code over and over again, or repeat code, okay? This can be very, very useful in coding or programming. Okay, now while loops we have to be a little bit careful with because they will just continue to run. So we have to usually provide it with a condition, and once that condition is met, then the loop will break. Or we can do something else, and I'll go over that as soon as we go over the condition approach. So let's go ahead. Oh, that's done. I will be playing that soon. Let's go ahead and create a variable called votes. Okay, and let's set this equal to 0. Now, what do we want to do? We want to run a while loop while votes is less than 5. Okay? So what this loop is going to do is it's going to ask somebody for their vote. It's going to increment this vote by 1, and then once this variable reaches 5, then this while loop will break. So why don't we just go ahead and ask somebody for their vote. We'll set it equal to input, and we'll say, please enter cheese or let's say cheese or pineapple. Okay, and this is just kind of like two random pizza flavors. Mom and dad are going out to get pizza, and they want to know whether we want cheese or pineapple. Okay, and why don't we do something like this too? Why don't we make this interesting? Let's just say pine equals 0, and then we'll say cheese equals 0. Okay, and what we're going to do is we're going to evaluate vote. We're going to say if vote equals cheese, then we're going to increment cheese by 1. So we're going to say cheese plus equals, okay? This is a reassignment. So it's taking cheese, whatever the value of cheese is, right now it's 0, and it's reassigning it and incrementing it by 1 at the same time. All right. So let's go ahead and put an elif here. We'll say elif vote equals what is it, pineapple? Then what we'll do is we'll increment pineapple by 1, okay? So we'll say pineapple, pine, I used pine, plus equals 1. And then what do we want to do at the very end of this while loop? We want to increment the votes by 1, okay? So we'll say votes plus equals 1. All right, and now what we'll do here is we will evaluate pine and cheese. Okay, so what we could do is we could say if pine is greater than cheese, what we could say is we'll print pineapple, it is. Else, that means cheese 1, and we'll say cheese pizza for dinner. Okay. And I'll go ahead and do that. So excuse me for my typing. Actually, I damaged the tip of one of my fingers lifting something heavy up in the garage. It's not a big deal, but it's kind of messed up my typing a little bit. Anyways, let's go ahead and run this program and see how it works. Stop and rerun. What is the length of your object? Oh, we have to right click. And we're going to enter, let's go with cheese. The next one will be pineapple. Let's do pineapple again. Let's do cheese again. We have a tie, so this is the tiebreaker right here. And I'm going to upset a lot of you. I'm going to go with pineapple, okay? Now, the while loop is going to break because the votes was incremented, and now it's become 5, which is not less than 5. So this condition ends up being met. The while loop breaks, and then it goes down to line 14, and it evaluates these two variables that we made, pine and cheese. Okay? So let's go ahead and write another while loop that doesn't have a condition. Okay? Perhaps we don't know what condition it's going to be. So let's comment this out. Sometimes we don't have a condition. Okay, we don't know what the condition is going to be. And there's two approaches to this. We can use a flag, or we can use what's called a while true loop. Now, they're both kind of frowned upon, but I would rather use a while true loop any day over a flag because they're both not that great to use, but I feel like they're both unavoidable because you just don't always know when what the condition is going to be. And if anything, the while true, at least that reduces one line of code for us. So let's go ahead and use a while true, and let's avoid using a while loop with a flag. So let's say while true. Now, this is going to run infinitely, but we have a solution, okay? And I'm just going to ask someone something very simple, okay? So I'm going to say, I'm going to ask them to enter their name. So I'm going to say name equals input. Please enter your name. And then what I'm going to do is I'm also going to tell them they can enter Q to quit anytime. Okay? And let's put the colon in the space here. And let's just put a ... Oops, sorry. All right. So let's go ahead and print their name. And now let's go ahead and run this program. All right. So I'm just going to put Dave, Steve. This code is going to run infinitely. It's never going to stop. So what we have to do is use the keyword break. Okay, so what I would say is this. I would evaluate name. Let's evaluate their name first. We'll say if name equals Q, then we're going to use the break keyword, and what that will do is tell Python to break this loop. Otherwise, what we'll do is we'll just print their name. So let's go ahead and print name. And let's go ahead and run this. Let me get rid of some of these spaces. You should never have more than 2 empty lines to maintain proper PEP 8 styling. Okay, why do we maintain proper PEP 8? Readability. We always want to be able to read our code. Let's go ahead and run this. Stop and rerun. And I'm just going to put Steve, Bill, let's do Sarah, let's do Amy, let's put my name. And now why don't we just go ahead and use Q, okay? Enter. And Q ends up, so when they enter Q, it ends up breaking the code because this evaluated to true, and therefore the logic that's tabbed over underneath it is going to execute. Okay, so again, these are while loops. We don't want to have an infinite while loop, so we just got to make sure that we're writing our logic properly. If you don't know the condition, use a while true over a flag. Maybe some other developers out there say use a flag. I hate using flags. I'd rather use this any day. But typically, you'll want to try to come up with a condition, okay? All right, so that's the end of this lesson, and I will see you in the next. Hello, everybody. I hope you're ready for the next lesson because we are going to be going over lists. These are very important in Python. And why don't we just go ahead and, as usual, create our file here at the top. And we'll just call this lists, okay? Now, what is a list? A list is just a collection of items, okay? And it can have as many items as you want, and each item is separated by a comma, okay? Now, a list can also be empty or just have one item. That's possible too. And also, the data inside of it is typically related. We can have any data type we want. We could have a string, an integer, but typically, like I said, the data is related. It doesn't have to be though, all right? They just work a little better when they are. Now, let's go ahead and create our first list, and we use square brackets to do it. So I'm going to create a list called cars, okay? And then I'm just going to use square brackets. And right now I have a list, okay? It's an empty list, but we're going to populate it. So let's go ahead and add a Tesla, comma, space, and then we'll go ahead and add a Ford. Let's do a Chevy, and then let's just do a Toyota. Yeah, we'll do a Toyota. Okay. So I have a list with 4 items in it, all right? And they also have index numbers, just like strings, okay? So Tesla's going to start at the 0 index number, Ford 1, Chevy 2, Toyota 3. 3 index numbers for a total of, well, not actually 4 index numbers, but 4 elements, index numbers 0 through 3. All right, so now that we have this list, let's go ahead and talk about a list and how it's mutable, okay? So I don't know if you've heard this term, you may or you may have not heard this term, but it simply means that I can alter this indirectly, all right? I do not have to come up here, click to add another item. I don't have to do that. I can do it indirectly from a separate line of code. And generally what we do is use methods to do that, but I'm just going to show you some manual selection first. So if I wanted to just select the Ford, I would have to write the name of the list, okay? And then I'm going to use square brackets right up against the list. Now, when you use square brackets right up against the name of the list like this, it becomes an index operator, okay? So now I have the index operator here, and I'm just going to put the index number, all right? And I think I was going to select, actually, let's just go ahead and select Toyota, which is going to be the last element. And now what I could do is I have Toyota selected, so I could just print it, okay? And make sure you right click, run. And there we go. We've printed Toyota. Okay. Now, I can also use the manual selection to update a value. Okay. And this is very useful. So what I would do is put cars, square brackets 3, and I could change the Toyota to say a Honda. And now if I printed this list, so we'll go ahead and print cars and run it, you can see the Toyota has been changed to Honda. All right. So this is the manual selection. All right. Now we can also use that to delete. So we would use the del keyword here, okay? And I want to delete, say, the Ford, okay? So I'm going to say del cars, index operator, and then 1, because we know Ford sits at the 1 index. Now, before we move forward into methods, I just want to quickly discuss negative indexes, okay? So this is 0 through 3, but the last element, you can also start from the last element, whereas this would be -1. So everything has a negative index number as well. But we start from -1, not 0, okay? So -1 would be Toyota, -2, Chevy. Actually, Toyota's been changed to Honda, but not until line 5, okay? So that's one thing I just want to quickly discuss. Python reads from top down. So it's not until line 5 that the Toyota becomes a Honda. From line 4 all the way to line 1, in this list, the Toyota stays a Toyota, all right? Again, Toyota starts from -1, Chevy -2, Ford -3, Tesla -4, all right? Now, let's just go ahead and print cars and run this. And you can see that this del keyword did indeed remove the, what do we want to remove? The Ford. Okay, great. So what I'm going to do is I'm going to comment these out just so we know which list we're working with. I don't want any of the elements to change. I just want to see them up here. All right. And let's just go ahead and start working with some of the methods. We'll try to get through as many as possible. So the first thing I want to show you is how to add to a list. Okay. And we typically use a method called .append. All right. So I'm going to say cars .append, and then I'm going to pass an argument in, and it's going to be a string. And what do I want to pass in? Let's go ahead and pass in a Lambo, okay? Now, if I was to print cars and run this, you can see at the end, there's the Lambo. So when we use the .append method, we just have to be aware that it does add to the end of the list. Now, there is a method to add an element at whatever index you want, and that's called insert. However, I don't use it that much. I typically just use append. So we would say cars.insert, and then I want to put the index number where I want to insert a car. So let's just say at the 2 index, comma, space for our second argument, and at the 2 index, I want to insert a Bugatti. Okay, so now if I was to print cars, you can see at the second index we have a Bugatti, and everything shifts to the right. All right, so let's go ahead and move on. Let's talk about removing from a list. Again, we can always use the del keyword up here, but I actually like to use the method when I'm removing. So what I would do is say cars.remove, and then you pass in whichever car you want to remove. And let's just go ahead and remove the Ford again. All right, and let's go ahead and print cars. Okay, and you can see that the dot remove method also removes, just like the del keyword does. Now, it's important to realize that the del keyword, or just using delete and remove, this takes the value out of the list and it's gone forever. All right, totally gone. You can never use it again. It's been thrown away. But there is another method that we can use that doesn't throw the value away. It simply pops it out of the list, gives it to us so we can have it. It returns the value to us, and then we can do whatever we want with it. Now, a good example might be something like this. Would I want to remove the Toyota and throw it away because it didn't pass emissions? No. What I could do is pop it out, and I can have this separate list, okay, called failed emissions. And what I'll do is pop the Toyota out, and I'll put it in failed emissions until it gets fixed, okay? And then I could put it back into the cars list. And that might be like a kind of an, I guess, somewhat of an example of using the dot pop method. I'm not going to throw the Toyota away just because it failed emissions. I want it to be fixed. So let's go ahead and do that. So I'm going to say cars dot pop, okay? But the dot pop does not support passing the name of the element. You have to pass the index number. So I want to remove the Toyota, and we added a Lambo and a Bugatti. We removed a Ford. So if we look down here, okay, yeah, this is our latest list. Okay, and it's going to be at the 3rd index. So I'm just going to pass a 3 here. And now that I've done this, I can actually just store this in a variable because it gets returned to us. So I'm going to say popped equals cars.pop3. And then how do I add to a list? Well, I want to put it in the failed emissions list, and it's highly unlikely that the Toyota would fail emissions because we know they're very reliable. And also it's unlikely that the Tesla would fail emissions too. So it'd probably be like the Ford or the Chevy, or actually the Lambo or the Bugatti, because I don't know how reliable they are. Anyways, let's go ahead and put that in a list. Again, we use the dot append method. You can use dot insert, but I wouldn't. So we'll do failed emissions. We'll say failed emissions, dot append, and then we'll just put popped in there. And now let's print both lists, okay? So we'll print cars, and then print popped. Let's go ahead and run this. And you can see it's been removed from the cars list, and now it's just inside of the popped list. All right, so, oh, sorry, I didn't mean to print popped. I wanted to print failed emissions. And you can see that I didn't print the list, failed emissions. I actually just printed the Toyota because there's no square brackets around it. So let's go ahead and run this. And you can see we have the Toyota. Okay. All right. So that's the dot pop method and the dot remove method. Let's go ahead and look at some other methods. One thing I actually like to do is use PyCharm to my advantage. I mean, it is your IDE. You should be using it to its fullest potential, or as much as you can. All right, to help assist you in developing software. So what I'd like to do is type the name of the list and use the dot operator, and then I just like to look at the methods. Hey, is there something in here that I want to use? Let's go ahead and do a let's do a sort, okay? Now, what does this method do? This method permanently sorts the list, okay? So it'll be in like alphabetical order, and I believe numbers come first, but we don't have to worry about that in this list. It's just all lowercase. Again, I like to use lowercase because it keeps things uniform, all right? I know that I'm not looking for uppercases sometimes and lowercases other times, and there's ways around that, but for me, it's just easier to just use lowercase. When I want to use uppercase, I use methods to beautify it. All right, so let's go ahead and print cars now that it's been sorted. And we can see up here, that's the last instance of the list before we sorted it. And then if you look down here, it's been sorted. So the Bugatti is first now. Okay, so that's the dot sort method, but perhaps you don't want to permanently sort it. One thing you can do is you could just like print sorted and then pass it in here. Okay, this is a non-permanent way of doing it. Temporary. It's a temporary sort. All right, I'm going to actually get rid of that though, because it's already sorted for us. And let's go ahead and continue on. So I'm going to do a cars dot, and let's go ahead and talk about extend. Okay, I find this method a little bit useless. I mean, I'm not saying it is useless, but I don't use it that often. And what extend allows us to do is add multiple items. How do we do that? We just pass another list here. Okay, so what we would do is just add, let's add a bunch of vehicles. Let's add two, not a bunch. I don't know, Pagani. I'm just adding a bunch of like cars that I've seen on Forza. Let's go ahead and add a Corvette. Okay, I don't even know if that's how you spell Pagani. Well, we're gonna go with it. Okay, I'm actually, now that I'm using this, I'm seeing an instance where this would actually be more useful. But let's go ahead and print cars. So let's run it. And you can see, what does the dot extend method do? It also adds to the end. But again, it just takes multiple elements. I think you can, actually, you could put as many as you want in here. But typically, I guess maybe the dot extend method might be a little bit easier now that I'm looking at it. But typically what I'll do is I'll just reassign. So I'd be like cars equals cars plus. And then you can actually add this list. You could have just taken this list right here and you could add it right here. All right. And that will do the same thing, but I don't know, maybe the dot extend method's a little bit better. So let's just go ahead and delete that. And why don't we continue on? So we'll do a cars dot. And what I want to do is I want to go over clear. Clear is actually, I don't even need to show you, because what it'll do is it'll just clear our entire list, but the list will remain. Okay, so cars will still exist. It'll still have a memory location. It just won't have any elements in it. So I don't really need to show you that, because once the list is cleared, we won't be able to use the other methods. Now, what I do want to show you is, let's go ahead and do count, and then we'll do copy. So cars dot count. This does the same thing as the string method that we worked with earlier. And what you can do is just pass in a variable. Not a variable. You can pass in a value. And why don't we go ahead and pass in, I don't know, Corvette. So we'll say Corvette. And let's go ahead and print this. Let's run it. And you can see it's returning 1. That's because there's one Corvette in this list. It does the same thing, like I said, as the string method. It's just going to count the occurrences. That's all. All right, let's go ahead and discuss the copy method. But before I do, what I want to do is create another list. Okay, I'm going to say cars v2 equals cars. So now what I'm saying is this list, okay, or whichever one it is. I think it's this list. Either way, what I'm doing is I'm actually referencing the first list, okay? I'm not creating a copy. You might think that this is creating a copy. So let's go ahead and print, just so I can show you. I can print the ID of cars, and then I can do it with cars v2. Let's run this. You can see they're both sharing the same memory location. So you may think that you have created a copy, and you might start altering this list. You might say, okay, well, I don't want to do anything to cars, but I have this cars v2 copy, and I'm going to add a bunch of cars in there. And I don't want anything to happen to the original list cars. But because this is a reference, you're sharing the same memory location. Anything you do to cars v2 will be done to cars. So how can you avoid that? Well, you can make a copy. I believe there's like a little operator to do it as well, but I can't remember what it is. So what I would do is just say cars v2 equals cars.copy. Okay, let's run this. And now you can see the memory location is different. So now you actually have a genuine copy that will not affect the original list of cars. Okay, so let me just look through to see if there's any methods left. So I'm going to put a cars dot, and if there's nothing, what we'll do is we'll just go ahead and end the lesson here. Okay, it looks like there's nothing really left for me to go over. So great job, and I will see you in the next lesson. Hello everybody, I hope you're ready for the next lesson because we are going to go over for loops, okay? So as usual, we'll come up, we'll right click, create our file, and name it for loops. Okay, so what is a for loop? Well, it allows us to iterate over a sequence of elements, okay? What is a sequence of elements? Well, generally it's a list, okay? But it could be any other iterable object. Now, how do you know if an object is iterable? Well, let's start off by creating a list. We'll call this fruits, okay? We use our square brackets, and then I'm going to put apple. I'm going to put peach. I'm going to put lime. And what else do we want? Maybe like lemon? Yeah, we'll do lemon. Okay, so we have this list here. How can we see if this is an iterable object? Well, generally that just comes from experience. You're just going to know what you can and cannot for loop through. But another way to tell is to use the dir function, okay? So this is short for directory, and then we'll just pass in the object, okay? So let's go ahead and run this. And if we look through this directory, we're going to see, where is it? Iter, okay. So we have the iter method here. This means that's an iterable object, and therefore we can for loop through it, okay? So let's go ahead and delete this line 3. We don't need it, okay? I'm just going to clear this really quick by running again. And now let's start off by writing a for loop. So what we do is we use the keyword for, okay? And then we name our loop variable, okay? So I'm going to name this item. This is actually pretty common. Okay, and then we use the in keyword, and then we put our iterable object here. Again, a list isn't the only iterable object in Python, but for now, for this lesson, let's just pretend it is, okay? So for item in fruits, we have our loop variable, and this is kind of like a shapeshifter, okay? This is going to become each element for each loop. And then what are you going to do with this loop variable? Well, sometimes you don't do anything with it, but we're going to in this case. So let's just go ahead and print item. Let's run this. And we can see apple, peach, lime, lemon. So what's happening here? This variable is shape-shifting into the apple, and then it's printing it. And then the loop runs again. Okay, so for the second loop, item shape-shifts into peach. And then we print peach. And then we for loop again for the third time. Item becomes lime. We print lime. And then again for the fourth time, item becomes lemon. We print lemon. And then we've reached the end of this sequence, so we're no longer going to for loop. The for loop will break, okay? So we can do a lot of stuff with a for loop. I typically like to use for loops, okay, to analyze elements in a list. But that's not the only way you can use a for loop. In fact, you can use for loops to just generate code or loop code for a specified amount of times. It doesn't have to be for iterating through, a sequence, okay? So let's go ahead and create a condition here, okay? I'm going to create a condition that says if item equals apple, then what do I want to do? I'm just going to do something simple. I'm going to print I found the apple. Okay. And then I actually can put an else here. I'll put an else. And let's print I am not an apple. Okay, let's go ahead and run this. Okay, so you can see that the very first line here is I found the apple, all right? And that's because apple is the first element. So item became apple first. And then everything else, of course, is not an apple. Now, what if I was to add another apple at the end? Let's run this. And you can see that the first element is an apple, and so isn't the last element. Now, I quickly want to discuss the two equal signs here, okay? Two equal signs is an evaluation. One equal sign is an assignment operator. You have to understand the difference between the two, okay? And, even I still make this mistake. Sometimes I just put one equal sign just on accident. And I don't do it often, but it does happen. Again, this is an assignment operator. It's how we would store data into a variable. Whereas this is going to evaluate, okay? Does item actually equal apple? Well, then, if so, perform this logic. Okay, so that's a for loop. Now, this is a traditional for loop, and again, there's no limit on how complex you can make this for loop. I mean, you should try to not make anything complex when it comes to coding because You know, coding's already hard enough. I know we're working with Python and it's a little bit easier to write than other languages, but coding is still hard, okay? So you should always try to reduce complexity if you can. But there is no limit to how complex your for loop can get. You can have nested conditions, and obviously if this if condition is inside of the for loop, it's a nested if condition, okay? Now let's go ahead and enter down, and let's do a traditional for loop, okay? Sorry, this is what I would consider a traditional for loop. This is a range for loop, what we're going to do right now. So I'm just going to say for I in range, okay? And now we're using the range function, and range will generate, I believe, a tuple or a list of numbers. Now we'll get into tuples later, but they're very easy. Same thing as a list. Anyways, this is going to create some numbers, okay? And I'm going to specify like 90 here, okay? So as you can see, I am not looping through a sequence, all right? I'm not iterating through a sequence. So you don't have to iterate through a sequence for to use a for loop. That's not the only thing you use a for loop for. Now, I is actually going to become 0 through 89, okay? This is non-inclusive. So if I wanted to add or include 90, I would put give me 1 through 90 plus 1. Okay, and now I'm going to loop 1 through 90. So let's just go ahead and print I. Let's run this. And you can see I do get 1 through 90, okay? And it's also still running this for loop. But if I was to start here, go all the way down, yes, we do get 1 through 90. Now, again, I'm not looping through a sequence here, so there's a lot of stuff that I could do. Perhaps I knew that there were 90 people coming to my party, okay? I'm throwing a Halloween party or something. And every time somebody comes in, I want them to be able to input their name into my program so I can save it to a text file or something. Well, what I could do is I could set up a specified number of loops, okay? This program will run 90 times for all 90 people, okay? I don't even have to use I, all right? So again, this is a traditional for loop, and this is like a range for loop. Now, what's interesting about using the range for loop is that we can use this I as an index number. So how could we do that? Well, let's go ahead and delete print, delete this. And what I want to say is I want you to loop the length of fruits, okay? So this is going to loop 5 times, all right? And it's going to give us 0 through 4. Well, that just so happens to be the index number of each one of these elements. So what I can do now is I can kind of use this range loop in the same way this traditional loop works. I can say print, and then I use that manual selection that we had gone over in lists. I put square brackets, and then I can put I in here, right? Because I is also like a shapeshifter. It's going to become 0, then it's going to become 1, then it's going to become 2, 3, 4. And so I'm essentially printing fruits 0 for the first loop, run the loop again, print fruits 1 for the second loop, etc. Okay, so let's go ahead and run this, and you can see I get apple, peach, lime, lemon, apple. All right, so what's useful about this is that this allows us to manually update. There is no method to update a value inside of a list. So if you need to go through and update each value, you'd probably want to use a range loop. Now, believe it or not, there's a better way to do this. It's called enumerate. We'll go over that later. I typically avoid using range loops. I don't fully avoid them. I still use them, but enumerate's a little better. We'll go over that after. So I'm going to go through each element, and I'm going to add an S at the end, okay? So now we have, instead of singular fruits, we're going to have plural fruits. So what I'm going to say is fruits I, put an I here, now equals fruits I plus an S. Okay? And what I'll do is I'll print fruits, run it, and look what we have now. So this sometimes can be more useful than the traditional for loop. However, there's another for loop that's even better, okay? And it's just by using enumerate. So let's go ahead and do that. What it does is kind of combines the functionality of both of these loops together. So what I'm going to do is I'm going to say for, I think it's index. So we'll say for index comma value in enumerate. Now, if you look here, this has a C. Okay, that means this is a constructor. And what it's going to do is it's going to take our list up here and it's going to construct it into an enumerate object. Okay, so what I'll do is put enumerate here, put the parentheses, and now I'll pass in the list. And now if I was to just print index, comma value, and run this, you can see that this is very, very useful, okay? Because we're getting the index and the value. We know that apple lives at the 0 index. Peach, well, actually, this actually should be peaches, but peach S lives at the 1 index. Limes lives at the 2 index, etc. Okay? So this could be very useful. I highly suggest instead of just going right for a range for loop, you just use enumerate, okay? Now let's do the same thing we did on line 11. Okay, what we'll do is we'll say fruits index equals value plus S. Okay, a little bit easier because I don't have to specify fruits I again. I don't have to rewrite this line of code. I can just write value. And actually, let's put a S, something like that, so we can see that it did indeed work. And let's go ahead and print fruits. Let's run this. And you can see this works too. And again, this is much more useful. I don't want to get too complex in this lesson, but if there's a problem where you're like, oh, I need the functionality of the traditional for loop, but I also need index numbers, then just go with an enumerate for loop. Okay, so that'll wrap up for loops. Okay, they're very simple. We don't want to overthink these. Okay, we don't want to be intimidated by these. They're very simple. Of course, they can get complex, but we're not going to do that in this lesson, okay? So great job, and I will see you in the next lesson. Hello, everybody. I hope you're ready for the next lesson because we are going to be going over dictionaries. Okay, so as usual, we'll go ahead and create a file, okay, and we'll call this dictionaries. Okay, perfect. Now, what is a dictionary? Well, it's a sequence, okay? It's sort of like a list, but lists have an index and a value, whereas dictionaries have a key and a value, and we get to define that key. So it can allow for very fast lookups, okay? Very fast access. I love to use dictionaries. So how do we write them? Well, we use curly brackets, and let's go ahead and use the cars example again. We'll put curly brackets here. And now we have a dictionary. Well, actually, we have a set right now, but don't worry about that. It's a dictionary once we start writing key value pairs. So let's go ahead and put a key value pair. Let's do a Toyota. And then we put a colon here, and we'll do Tacoma. Okay? That is our first key value pair. All right? And now we'll put a comma, we'll put a space, and let's add another key value pair. So let's just do a Honda, colon, Civic. Okay? And then lastly, we'll just go ahead and add a Ford F-150. Okay? All right. So we have our dictionary here. How do we add to the dictionary? Well, first off, we need to understand that just like lists, dictionaries are mutable. That means we can change it indirectly. We can manipulate it indirectly. I don't have to come up here and add another key value pair. I can do it from outside of the dictionary. So to do that, what we do is we name the dictionary, or just write the name of the dictionary, use our index operator, but in this case, we're not accessing indexes, we're just adding a key. So we'll say we have a Ford, let's just go ahead and add a Tesla, and then we put an equal sign, and then we put the value, okay? And what I'll do is just add a Plaid, okay? I think that's their fastest car, I'm not sure. Anyways, this will actually add to the end of a dictionary. Okay, so there's no dot append method for dictionaries. Let's go ahead and run this. And remember to right click. And you can see that it adds to the end. Now, what if I tried to add another Tesla? Well, we can't do that because you can't have duplicate keys. So I'm going to demonstrate that right now. We'll say Tesla equals, and let's just do a P90D, I think, okay? Now, if I was to print this list, this dictionary, sorry, and run it, you can see it didn't add another Tesla. It simply overwrote the value, okay? So again, we cannot have duplicate keys. All right, now let's go over some of the common methods as well, All right, let's enter down a couple lines. Now, one thing I do want to point out first is that this is underlined with yellow squigglies. I think it's because it wants me to use a constructor, but either way, I'm just going to show you how we can create a dictionary another way using a constructor. So what I would say is something like this: cars2 equals, and I would say dict. Okay, then we put our parentheses, and then we can just add keyword pairs right here. So I would just, it looks a little bit different, but I would say something like this. Dodge equals Ram, comma, let's do Chevy equals Corvette, and we'll just add one more. We'll say, what do we want to do? Kia equals Sorento. I think it's a Sorento. Anyways, this is also another way to create a dictionary, okay? But I typically use curly brackets, all right? So if I was to print cars2 and run this, you're going to see it does the same thing, okay? We have a dictionary with key value pairs. Okay, let's move on and let's get into some of the methods. And what we'll do is we'll just use methods on our top dictionary here. So let's go ahead and say cars, use the dot operator as usual. And let's go ahead and do items first. It's right here. Why not? Now, what cars.items does is returns us a list of all of the items or the key value pairs. So this would be an item, this would be an item, and this would be an item. And it's going to be in a list. So we can print this, run it, and there you see we have the list with the square brackets. And what's inside? Well, inside are these tuples with a key value pair inside of it. What is a tuple? A tuple is a list. It's the same thing, but they're immutable. They cannot be altered, okay? And that makes them pretty useful for protecting data, and they're a little bit faster too. Okay, so let's go ahead and move on. That is the dot items, but what if I only wanted, say, all of the keys? I could say cars.keys. Okay, let's run this, and you can see I get a list of just the keys. And then if I wanted just the values, I could say print a cars.values, okay? And here we go. We have a list right here of all of the values. All right, let's move on to some other methods. Let's go ahead and say cars dot. Let me remove this bookmark. Cars dot, and why don't we do pop? Well, dictionaries, they don't have a dot remove method. So there's two ways you can delete from a dictionary. One is the cars.pop method, okay? So what I would do is just pass in the key here, and let's just pass in Honda. And if we print cars and run this, you can see the Honda's been removed. Another way to do it, I believe we can use the del keyword. And what I would say is cars, square brackets, and let's just go ahead and pass in Toyota. Then let's print cars, run this, and you can see that this method works as well. So you can use dot pop, and perhaps you're going to want to use it because you want to save the value. Remember, dot pop doesn't throw the value away. It removes it from the data structure, and then it returns that to you. Okay, so you may want to use it. But again, it only returns the value. So you're popping Honda out, but it's actually going to return the Civic, okay? Now, another thing we can do is I actually want to comment these out just so we can keep working with this original list, okay? So I keep calling it a list. It's a dictionary. I apologize. Now, another thing we can do is cars.pop item. What does this do? Well, it requires no arguments, and all it does is pop out the last item or the last key value pair, and it returns both of them to you. So if I was to print this, run it, you can see it popped out the Tesla P90D, okay? So again, it just pops out the last item. So that's a key value pair. It doesn't just pop out the value, all right? Let's go ahead and move on. Let's do a cars.update, okay? And what update allows us to do is add to the end of the dictionary. Now I'm going to show you this. I'm going to show you another approach after. Let's go ahead and add by doing something. What do we have in here? Let's go ahead and add, because this is in another dictionary. We can add some of these. So I would say Dodge, Ram, okay? Put a comma, and then we'll just do Chevy, Corvette. Chevy, Corvette. Okay. Let's go ahead and print cars now. Let's run this. And you can see that the dot update method adds to the end. Okay, it adds to the end of the dictionary. There is another way to do it using the pipe symbol, where you might have two dictionaries. So for example, I have a dictionary right here. Let's actually cut that out. Let's comment this out. And let's enter down. And I'm going to say cars equals cars, pipe symbol, and then this dictionary. Okay, this will do the same thing. So if I run this, you can see it did the same thing. All right. Okay, let's go ahead and move on. So let's do a cars dot. And what have we not done yet? Clear is obviously self-explanatory. I don't want to go over clear with you because it'll clear the dictionary and then we can't work with it. Copy, well, it's the same thing that I talked about in our list lesson, okay? You don't want to just reassign, okay, or create a copy by using the assignment operator, because what that does is create a reference. They share the same memory location, and anything you do to your copy or the copy that you think you have is still going to directly alter the original list. So again, you would use the copy method to create another memory location, and now you actually have a real copy of it that you can manipulate that will not affect the original dictionary. All right, so we're not going to touch copy right now, and we're not going to touch clear, and it looks like we can just go ahead and move on. I want to teach you about for loops with dictionaries, okay? We still use the same syntax. So we still use the for keyword, okay? We still name a loop variable, and then what we would do is use the in keyword and then just name our dictionary, okay? Our dictionary is called cars. Let's put a colon, let's tab over, and let's just go ahead and print item. And let's run this. Okay, and you can see that it's only printing the keys. So this isn't necessarily ideal. A lot of times when you're looping through a dictionary, you kind of want to access both the key and the value. All right, so what I recommend doing is just automatically defaulting to this type of for loop where I say key value. So now we have two loop variables, and then we would say cars dot items. Okay, and then we can just go ahead and print the key and value here. Let's go ahead and run this, and you can see now I'm getting both the key and the value. Now perhaps you just wanted the value. We know that key is default, so we get all the keys by default. But if you want all of the values, what you can do is say for value in cars dot let's do dot values, and then we could just print the value. Okay, so let's go ahead and run this, and you can see now we just get all the values. All right. So for looping is generally the same with dictionaries. It's just a little bit different depending on how you want to work with it. If you just want the values, you got to use the cars.values method. If you want both the key and value, cars.items, and then by default, you can just loop through the keys. Okay, so that is dictionaries, and that will wrap up this lesson, and I will see you in the next. Hello everybody, I hope you're ready for the next lesson because we will be going over sets and tuples. Okay, so as usual, we'll come up, we'll right click, and we'll create our file. We can call this sets and tuples, okay? Now, let's just quickly go over a tuple because there's not a big difference between tuples and lists. Tuples are just, they're immutable lists, okay? So we can't change the data inside unless we do it directly. Now, this could be good for protecting data. For example, days of the week, okay? Those aren't going to change. So we might want to put those inside of a tuple. So why don't we go ahead and do that? We'll just call it days. And then what we do is we use round brackets here, okay? And then we can just put like Monday. Actually, we'll do MON. We'll just abbreviate. So Monday, Tuesday. Let's do Wednesday. Let's do Thursday. Let's do Saturday. And then we'll put in Sunday. Okay. So if I was to hit days, not hit, but type days and then hit the dot operator, you can see we have no methods here. The only thing that we can do is count the amount of occurrences of a particular element or get the index of that element, okay? We can also for loop through it as well. So if you need to for loop through it, analyze each element, and then do something with them, you can do that. But again, it's immutable. So you would have to like take those elements out and put them in a new list, and whatever you do with those elements, you can pass those changes into the new list. Okay, so let's go over sets now, all right? I'm going to create a set called nums. Actually, I'm going to create two sets. So I'm going to put in 1990. These are just going to be like numbers. I probably should have named this dates, but no big deal. We'll do 1990 again. Let's do 1990 again. Let's do 2005, 2001, 2010, 2019, let's do 2019 again. And why don't we do 2003. Okay, so I have all of these dates inside of a set, and actually I'm going to create another set. I'm going to call it nums v2, short for nums version 2. And let's go ahead and put a 1990 in it. Then let's put a 2000. Let's do a 2001. Actually, I've already have a 2001 in the set above, so we'll do a 2002, 2003, 2004, 2006, 2007. Okay? Now, these are unordered, and they do not allow duplicates. So if I was just to print nums, we know that we have some duplicates in here. For example, we have 3 1990s, and we have 2 2019s. So let's just run this. And you can see it got rid of all the duplicates, but it's also unordered, all right? So every time you run this, it could stay in the same order or it could change order. It's unordered. And you can see because we started with a 1990, but if you look down here, it starts with a 2001. Now let's go over some of the methods, okay? So I'm going to type nums. I'm going to hit the dot operator. And then let's go ahead and check out add, okay? This allows us to add an element to the list. Actually, the set. It's just like a list. It's just like the dot append method. And I'm going to add another date. So let's just do like 1995, okay? And let's go ahead and print nums. Let's run it. And you can see 1995 has been added, all right? Now, let's go ahead and do a nums dot. And I think I want to do intersection. Okay, now what this should do, let's hover over this. I believe it gives us all of the same elements, okay? Return the intersection of two sets as a new set. So I want the intersection of nums and nums v2. And actually, we don't want that capitalized, so I think it's Control-Shift-U. Okay, perfect. Now let's go ahead and print. Why is my caps lock on? Print. Let's print that method, actually. So I'll go ahead and print it. Okay, now you can see if you ignore this, this gives us a new set, right? And what it does is it gives us numbers that are in both sets, okay? And it returns it as a new set. So that's how the intersection method works. Now let's go ahead and let's print a nums dot, let's do difference. Okay, and you can probably guess what this is going to do. Let's run it. And it gives us all of the numbers that aren't the same, all right? Now, let's go ahead and do another method. Let's go ahead and print a nums dot. And why don't we do a remove, okay? Now, you probably already know what copy is. It's the same thing. Pop is also the same thing, but I want to show you remove, okay? Because there's something with remove that I want you to know. So if you can't find the number, you'll end up getting an error. So let's just put a 2020, okay? And let's run this. And you can see we actually get an error. So if you don't know whether something exists or not inside of like an element exists inside of the set, what you can do is use the discard method. So we'll say nums.discard, and then let's put a 2020. And you can see it returns none, all right? So that's why I wanted to show you remove. A lot of times it's actually better to just use discard, just because, you know, it's a little bit safer, okay? Now let's go ahead and check out some more methods. Let's not print anything just yet. Let's say nums dot. One thing we can do is union, okay? And what this will do is just actually combine the two sets together. So I could say nums v2 in here. And now if I was to print this, run it, you can see it combines everything, okay? All right, let's move on. Let's print a nums dot clear. You probably know what that does. And it looks like that's really the only thing that we have to go over. Sets, again, they're super useful. I mainly use sets because they just don't allow duplicates. And it allows me to reduce the amount of data, or reduce the amount of redundant data that I'm actually trying to manipulate. So I can convert something to a set to get rid of all the duplicates before I continue on with my script or my program or whatever it is I'm trying to achieve with my data. Okay, so that is the end of the lesson, and I will see you in the next one. Hello, everybody. I hope you're ready for the next lesson because we are going to be going over functions. And as usual, we'll right click up at the top directory. We'll create a new Python file and we can call this functions. Okay, so what is a function? Well, a function is simply like a block of code, an encapsulated block of code that runs when you call it. So it's kind of like a tool, all right? Now, there's a number of built-in functions in Python that we've been using for the entire course, okay? And one of those obviously is print, okay? It only prints, or it only displays when we call that function, and generally we'll pass an argument in to tell Python what to display, okay? So functions are really, really useful for reusability, okay? We can reuse functions over and over again. If you have a bunch of functions that you love to use and they're all kind of similar, you can just store all of those functions in a file and you could import it and then start using those functions in your code. So they also make our code more modular, all right? So how do we write a function? Well, simple. We use the def keyword, okay? This is short for define. Now, in some parts of the world, I've actually heard people call functions definitions, but that's not the correct terminology. These are functions, all right? We're going to start off with something very simple. Let's create a function called greeting, okay? Now, we use the def keyword, then we name our function, and then every function must have parentheses after the name, okay? And what do we pass into these parentheses? Well, generally we'll pass parameters in here, but we're going to leave this one empty. So let's go ahead and put our colon, and now we enter down, and anything that's tabbed over, of course, is going to be a part of this function. So let's just create a greeting, okay? Let's just print hello, okay? Okay, so we have written our first function. This is not going to run unless we call it, all right? So we have to call it. And the way we do that is by typing the name of the function, followed by the parentheses. These parentheses are the call. If you don't put these parentheses, you're not calling the function. It is not going to work. In fact, you're probably, if I was to print this, it's only going to show me the memory location, all right? So let's go ahead and run this. Remember, we right-click, run, and there we have it, okay? So we can just use this function whenever we want. It's reusable, okay? I could do this 4 times. Let's go ahead and run this again, and you can see we get hello 4 times. Now, this function isn't very useful, okay? And there's a number of reasons why, but to better illustrate that, I think we should create another function that is more useful. So let's delete these calls, okay? We don't care about this function right now. And let's create another function called add. So we'll call it add. And this function is going to take 2 parameters. This allows the user to put input into their function, okay, to pass input into their functions. And we can name our parameters whatever we want, but I'm going to name them num1 and let's say num2, okay? Then our colon, and then what do we want to do with these parameters, okay? So what we want to do is, let's start off just by printing them. So we'll print num1 plus num2, and let's just go ahead and run this. We'll call the function, so we'll say add, and let's run it. Now, you can see it's requiring 2 positional arguments, okay? Again, these are parameters. I want you to think of these like empty boxes or placeholders. They're placeholders for your arguments. We pass arguments into the function call. So what do I want to put inside of this empty box, which we called num1? I want to put a 98 in here. Then I'm going to put a comma, and I have to pass in another number for num2, okay? So let's just go ahead and pass in 23, and let's run this. Okay, now you can see we get 121, but there's something that's not correct here, and that's print. We really shouldn't print our functions. I'm not saying we can't, but we generally want our functions to return value to us. Print has no value. It does nothing. It just shows us, all it does is display. It shows us something. And we don't want our functions to do that. We want them to return a value so that we can use it. Actually, before I return this, I'm going to show you why. If I was to store this in a variable, let's just say sum. Okay. Now, sum should equal 121, right? Well, it doesn't. If I come down here and I print sum and I run this, you're going to see it does still print the two numbers, but then it tries to store it in this variable. That's not possible because we're printing. Print has no value. And then what happens is it returns none, okay? So that brings me to that actual word, return. That's what we want to use when we want our functions to give us value back. So what I should do here is delete this print statement, and I want to return num1 plus num2. Now this function has value and I can take it with me. Okay, whatever this function produces has value and I can take it with me wherever I go inside of my program, okay? So if I was to run this again, you're going to see I just simply get 121. Now, what I like to do is I typically like to print my function, so I wouldn't really do it like this. This works too, depending on your needs. But I would just print, add, and let's just do 23 and 56. And let's run this. Okay, and we get 79. All right, so let's go ahead and create another function. All right, and what function do I want to create? Let's create an average function. Let's say def avg, which is short for average, and this is going to take just one argument. I'm going to call this argument args. Actually, why don't we just go ahead and pass a list in instead? So our parameter should be a list, and we'll just say list. We could do that. That's a reserved keyword. We really shouldn't use the word list. Let's just say list of nums. A little bit long, but it'll work. Okay, so we know we're going to pass a list into this function, and we're going to get the average. So imagine a student passes in a list of all of their grades, and they want to get their average grade. So what we could do is return, that way it has value. We'll return the sum of the list of nums, and what that's going to do is it's going to calculate, well, it's going to add every single number inside of this list, okay? And then we want to divide it by the len of nums, list of nums, I should say. So list of nums. And now if I call this function, and by the way, the len function simply returns the length. So if you give me 5 grades, well, this is going to produce 5. And then, of course, this is going to add all of those grades together. So, for example, we might have 500 divided by 5. And that would give us the average, okay? Now, let's go ahead and call this function by writing its name. And then this one requires a list, okay? So let's go ahead and pass a list in here with square brackets. And let's just put a 90, a 98, a 79, and an 87, okay? And let's run this. Now, I'm still getting 79, which is 9, line 9 here. That it's producing 79. Let's comment that out. Let's run it again, and you can see I'm not producing anything. Again, that's because we're returning. This does have value, but we're not printing it, okay? So let's just go ahead and print it so we can see. Okay, let's go ahead and run that, and you can see we get 88.5, okay? Now, another way to do this is actually by using args, okay? So what I'm going to do is I'm going to put args here. Actually, it's an asterisk and then args. Okay, and now I would want the sum of args divided by the length of args. Okay, this does the same thing, but it basically takes every argument and turns it into a tuple, and it's just a little bit faster because now I don't have to pass in these square brackets. I can just pass in as many arguments as I want, or an arbitrary amount. So let's go ahead and run that, and it still works the same. Okay. Now, let's go ahead and talk about default arguments and positional arguments. I'm going to create a function that, what do we want to do here? That displays car. We'll call this def display car. Yeah, we'll call it display car. All right. Now, this function is going to take a make, comma, model, all right? Now, I would consider these to be positional arguments, okay? And you're going to see why. I'm going to actually print this function because, like I said, you don't have to return every single function. So I'm going to print this, and I'm going to write an f string. I'm going to print an f string that says, I drive a curly brackets make, curly brackets model, okay? Now let's go ahead and call this function. Let's comment the call on line 16 out, and let's pass in a make and a model, okay? So let's have the make be a Toyota, and the model should be a Tacoma. All right, let's go ahead and run this. And you can see this works appropriately. Now, I would consider these to be positional arguments because you really don't want to put the model in first, okay? If I was to just reverse these, so let's cut this out. Control X, paste it, comma, space, remove that, and run this. You can see this just doesn't make as much sense. I mean, I'm sure you could figure it out, but I drive a Tacoma Toyota is just a little bit weird. So positional arguments, okay? They have to go in the right order, all right? Not always. For example, these wouldn't really require any position because you're just passing an arbitrary amount in. But these are not positional arguments, all right? It doesn't matter if I put 56 plus 23. It's the same thing as 23 plus 56. Not positional, okay? Now, let's talk about some default arguments too, all right? Let's go ahead and put a comma here, and let's go ahead and add year, all right? And I want to make this default, okay? So I'm just going to put a 2003, okay? So now I'm going to say I drive a year, make, and model. Now, this means that I should pass in three arguments, okay? But because this is a default, I don't necessarily have to. So let's go ahead and run this. And you can see it defaults to 2003 if I don't put the year in myself. Now, if I put in a year, let's just say 2019, and run this, you can see the argument that I pass in overwrites the default argument. So this is just a default, okay? Now, you could make it optional too, okay? Whereas like there's no default value. You either put in a year and it gives you this sentence that displays the year as well, or you just don't put in a year and it doesn't display it. So let's just go ahead and do something like that. I'm going to say year equals, and why don't we do something like this? I like doing this. You can also use none, but I'm just going to put an empty string here, okay? So I drive a year, make, or model. First off, let's just go ahead and run this. So you can see it looks fine, but what if I get rid of 2019 and run this again? You can see it's somewhat optional, but we do have a bit of a problem here, okay? We have two spaces. This doesn't really look right. So what we could do is create a condition inside of here. I could say if year. What does that mean? It means if this is not empty. Remember, if something's empty, it's false, okay? If it's not empty, it's true. Therefore, if I pass in a value, this is no longer empty, and this becomes true, all right? So then I would print this. Else, I would print, let's print an F string, and I'll copy this. And let's delete this. Let's run it. And you can see I drive a Tacoma Toyota. Again, we swapped these around, so these should be positional. Let's go ahead and fix that. Let's run it. Okay, I drive a Toyota Tacoma. So what's happening? This is no longer empty. This becomes true. This print statement executes. Otherwise, year is false, and this print statement will execute. And that takes care of that space for us. So let's put in a comma and put in a year and just see how it looks. Let's just put 2019 back in and run it. And it looks good. Now, we have to write some extra code because we're not using return. When you return, the function ends. Let me give you an example of that. We would no longer need the else statement. So what I want to do is delete the print here. Let's just go ahead and return. Get rid of this. And now I no longer need the else statement, because if year, this is going to return this. Otherwise, it'll just simply return what else I put here. So let's enter down and just say return here. And now I don't need the else, all right? In fact, I have to bring this up. All right, let's run it. And you can see, because we're using return, we're not getting anything displayed. So we print the call, run it, and now it's working perfectly. If I get rid of this 2019, run it again, working perfectly. So notice how return saved me one little line of code, all right? Now, those are optional and default arguments. Let's quickly talk about type annotations, okay? So let's go ahead and enter down a little bit. Now, these are called professional functions. When we use annotations, type annotations, people also call them type hints. This is called a professional function because it gives our user more information about what our function does. In fact, let's not even create another function. Let's just do it right here. To use type annotations, what we do is we put a colon, and then we put the data type, okay? We need to tell the user, hey, we want a specific data type. When you give me the make, don't pass a list in, don't pass a dictionary in, pass in a string, okay? All right, and I think we put a space here. And we'll do the same thing with model. We want a string for the model. So let's just go ahead and put str, all right? And now we don't have to use a type annotation on this one because it's a default argument, okay? So we just don't have to do it. Now, we should also tell the user what this is going to return. So we do that by putting an arrow here. And it's going to return a string, okay? And we also want to put a doc string, okay? So to do that, what we can do is we do 3 double quotes. So I'm going to do shift, double quote, double quote, double quote. And then I'm going to hit enter. And there you can see, I think PyCharm is doing this for me. And what I want to do is just give the user a little bit more information. This is a professional function. Again, this is called the doc string, and these are type annotations. These are not mandatory. They're just hints. It's telling the user, hey, this is what you should enter. All right. Now, let's go ahead and just write something up for the make. Okay. We'll say takes a string of the vehicle. We'll say vehicle make. Okay, I'll copy this. Takes a string of the vehicle model. The year, we could say, actually, because our arguments will overwrite the year, you could pass in an integer. So I'm just going to say takes an integer of vehicle year. Okay, and what's it going to return? It's going to return a string of vehicle info. Now I'm getting this little red squiggly. It's bugging me. So let's just try running this and see if that goes away. Okay, it does. I don't know why that's there. Seems a little bit weird. If I hover over it, a loose punctuation mark. Okay, well, we're not going to get too deep into that. Let's just go ahead and ignore it because it's working. All right, so now if I was to call this function, I'm actually going to delete this. And I'm going to write the name of the function, okay? And now you can see I have a little bit of information, okay? This box pops up. I have some information. And if I need more information, I can hover over the blinking cursor. And we can see down here, there's a little bit more information, all right? You can also write something up, about, what this function does, okay? And this is a professional function. You don't have to use them. You should use them. And it just gives more information on how the function works. Now, one last thing I want to discuss with you is if you're using optional or default arguments, they have to be all the way to the right, okay? So if I take this out and I put it here, you can see I get these red squigglies. They always have to come last, okay? A non-default argument can never come after a default argument. So let's just go ahead and undo that. And that will wrap up our lesson on functions. Again, just go over these if you want to. Just rewind this lesson back because functions are really important, okay? So great job, and I will see you in the next lesson. Hello everybody, I hope you're ready for the next lesson because we are going to go over lambdas. So as usual, we will right click, create a new file, and we're going to call this lambda, okay? All right, so what is a lambda? It's simply an anonymous kind of throwaway function, kind of like a one-liner function. And to better explain, obviously, I'm going to create a regular function. We'll call this add. And my parameters will be x and y, and I'm going to simply return x plus y. Okay. Now, how could I do this on one line? Well, I could use a lambda. Now, lambdas are super useful, especially when we use them in higher order functions, and we'll go over that in just a bit. But let's create our first lambda, and let's say we use the keyword lambda, and we want to have the same parameters. So we'll say x, comma, y. And then we put a colon, and then we just write our expression. So basically, we want to return x plus y. Noticing I'm not using the return keyword, lambdas automatically return the expression to the right of the colon. And again, to the left of the colon, those are your parameters. Now, I could store this in a variable, okay? So I could say add2 equals this lambda, but typically we just use lambdas in, again, higher order functions where we use it and that's it, all right? So I wouldn't really store this in a variable. Otherwise, I would just create a regular function. Now, let's go ahead and call add2 just to see if it's working. So we'll say add2, okay, and then we'll pass in 45, 67, and let's go ahead and print this. All right. Let's run it, and you can see this is working perfectly, okay? It's just adding the two numbers. So lambda functions work the same way as a regular function, except it's like a one-liner. And a lot of times they're a little bit more clear and concise depending on what we're trying to do, all right? So let's talk about these higher order functions where lambdas are really useful, okay? The two ones that are the big ones are map, filter, and there's also reduce, but we're gonna go over map and filter, all right? So let's go ahead and create one. And before I do that, I wanna create a list, and I wanna comment these out too. So I'm gonna create a list. So I'm gonna call it nums equals square brackets 12, 34, 56, 67, 34, again, and 21, all right? And now, say I wanted to perform a function on each one of these elements. Well, I could use this higher order function or the map function, all right? So let's say map, and then I want to define the lambda first, okay? That's going to be my first argument. Again, a higher order function is a function that takes another function in as an argument or returns a function. So let's pass in a lambda, and we only really need one parameter, okay? This is going to represent the element in the list, okay? So x is going to represent each element every time we iterate. We put our colon, and what do we want to return? I want to return x, say, to the power of 2, all right? And let's go ahead and put a comma, and then we pass in our second argument, which is going to be our iterable object, okay? So nums, all right? Now, if I was to run this, actually, let's go ahead and print it. Oops, I don't know what I did there. Okay, you can see after we print it, we just get this map object, okay? What we should do is typically we'll just convert it to a list so we can see it, right? So let's go ahead and convert this to a list. And now let's run it. And you can see that we get every single element in here. Basically, it's squared, okay? So it's all exponential math. Now, this is super useful. But remember, map works on every single element in the list. Perhaps you wanted to filter out some elements. Well, that's where filter would come in handy. And let's go ahead and create another list called products. Set it equal to a list. And this will be a list of dictionaries, okay? And the dictionary is going to represent a product. So I'm going to say name of the product will be an apple. Let's do a price. And we'll set the apples at, say, 100. Okay. Now let's go ahead and put our next product in. Curly brackets again. We'll do name. We'll do pair. We'll do price at, why don't we do 150 for this? Okay, and then we'll put one more product in. Let's do name again, of course. We'll do kiwi. And the price will be, let's do 190. Okay, so I have a list. You can see with the square brackets. What's inside of the list? A bunch of dictionaries, or actually 3 to be exact. Each dictionary represents a product, okay, with its name and its price. And I want to filter out every single product. I actually just want to filter products so that it's showing me products that are greater than 100, have a price of greater than 100. So let's go ahead and do that using the filter function. Remember, map function works on every single element. Filter filters out elements, and it's based off whether it's true or false, and you'll see how that works right now. So let's go ahead and print a list, filter, and then we'll pass our lambda in. Now, there's nothing stopping you from passing in a function here as well. I mean, a lambda is a function, but you could create a regular function up here, name it, and then pass that name into here. But again, this is just a little bit more clear and concise, okay? And honestly, you can throw it's basically you're throwing the function away after, all right? So this is going to require one parameter, x, okay? That's going to represent each element. And then what we're going to say is we want, let's get true if, x square brackets, this is how we index into a dictionary, okay? Price is greater than 100, okay? And then we put our comma in here, and then we're going to put in the iterable, which is going to be products, okay? Now, you're seeing a red squiggly here. Why is that? Well, it's because we have an if statement. If you have an if statement in a lambda, it requires you to follow it up with an else statement. So I would say else false, okay? So if it's true, they'll store that element in this list. And if it's false, the element will just not be stored in the list. It'll be ignored, okay? So let's go ahead and run this. And it looks like I ran on debug. And you can see it did exactly what we wanted, okay? If it had a price of greater than 100, then we filtered those elements into the list, all right? Now, perhaps I wanted to just show the names of anything that had a price of over 100. Now I could actually map those as well. So let's just go ahead and print list map, okay? And what we could do is store this. Why don't we store this in a variable instead of print it, okay? We'll say new products equals that, okay? And then I'm going to run the map on this iterable object. So I'll pass in the lambda x, and I want, the only thing that I want is x square brackets name, okay? And now I put a comma, and I'm going to do that on new products. And now let's go ahead and run this. And you can see now it's just giving me the names, okay? So these higher order functions are really cool. They're really useful. But believe it or not, I don't use them that much because we have something called list comprehension. And we're going to be going over that particular concept next. So that will wrap up this lesson. And I will see you in the next. Bye. Hello, everybody. I hope you're ready for this next lesson because we're going over list comprehensions, okay? These are really fun, so let's go ahead and get started. Now, as usual, we'll right-click, create a new Python file, and let's call this list comprehension. Okay, so we have this file, list comprehension, and now I want to write a list comprehension, but before I do that, I want to write a traditional for loop. Now, list comprehensions are really cool because they allow us to write a for loop inside of a list. And we can do it on one line. So let's just go ahead and create a list, okay? We'll set this equal to, We'll set it equal to a list, and we'll put 1, 23, 45, 67, 12, 34, and 89. Okay. Now, we have this list, and I want to create another list, but I want each element to be squared. So I would iterate over this, okay, and then take each element and put it inside of a new list. Now, we went over lambdas in the last lesson, and we basically accomplished that goal by using the map function, okay? But we're going to use list comprehension instead here. And I actually like these better, okay? I think they're just a little bit more clear, and they're easier to read. So let's go ahead and create another list, okay? So we would have to create nums v2, set it equal to an empty list, but we're going to populate it here on line 5 and 6. So we write our for loop. We want to iterate through nums. So we would say for I in nums, okay? Now, what do we want to do with I? We want to square it, and then we want to put it inside of this empty list. So we would say nums v2 dot append, and then we put the number in. So we would say I to the power of 2, okay? Now, if we were to print this list, run it, let's right click and run, you can see this works perfectly, okay? Now, how about we put a condition, all right? So I'm going to say if I is greater than, let's say 23, or let's do 34, then I want you to square it, okay? Otherwise, I want nums v2 dot append, and we'll do it to the power of 3. So we'll say I to the power of 3. Now let's go ahead and run this. Actually, let's do this to the power of 4, just so we can really see. It's a little bit more clear. And you can see wherever we did something to the power of 4, we have these astronomically large numbers, okay? So basically, we have a for loop, okay? And this took, 4 lines of code. So 1, 2, 3, 4, 5. Well, 5 lines of code if you don't include the for loop. But we have 4 lines of code down here underneath the for loop. Now, what if I could do that all on one line? Well, I can. Let's go ahead and comment this out. Let's go inside of our square brackets right here. And with a list comprehension, the first thing we do is tell Python what we want to be in the list. And again, I want it to be I squared. And then I write my for loop. So I would say for I in nums. Now let's just go ahead and run this. And what you see is it's going to square every single number, okay? So this is where the conditions come in. How can I write a condition? Well, if I only have one condition, I want to write that condition to the right of the for loop, okay? So I would say if I greater than 34. Let's go ahead and run this. And you can see now it's only targeting certain numbers. Now, what's unique about this is we're essentially filtering, okay? So if we look back at our lambda, we can see we filtered here, okay? We can accomplish the same goal most of the time with a list comprehension, and it's why I use them so often. Okay, now let's go ahead and create 2 conditions. So if I have 2 conditions, what I have to do is put them on the left. So I would say I want I to the power of 2 if I is greater than 34. Else, I want I to the power of 3 for I in nums. So again, one condition goes on the right side of this for loop, and 2 conditions have to go on the left side of the for loop. That's just the syntax. Okay, so let's go ahead and run this. And you can see this is working perfectly, okay? Actually, is it working perfectly? If it's greater than... Oh, I did this... Yeah. But I want it to the power of 4. Okay, great. So let's run this, and now we can see. I noticed the numbers were off a little bit, so sorry about that. Okay, so we're doing everything on one line of code. This is terrific, and this is actually really easy to read. Now, one thing you need to know, you have to be able to identify where a list comprehension will be suitable, and there's times where you just can't use a list comprehension. It's just not going to work. Okay, so list comprehensions are great. It's a great way to map and filter, but you can't do everything with a list comprehension. So keep that in mind. Sometimes you just have to go with the traditional for loop. Okay, so that is list comprehension. Let's actually take one more look, okay? I want to show you how we can accomplish this goal. So remember, we basically filtered anything that had a price greater than 100, but then we wanted to map it just by its name. How can we accomplish these two lines of code with one list comprehension? Well, let's take our products list over. So I'm going to Control C this, and I'm going to paste it in. And now we have this products list. And what I want to do is I want to create another list underneath it. And we're going to use a list comprehension. We'll call this, let's use the same name. We'll call it new products. Okay, so new products. Okay, now, what do I want with new products? I want the name. So I would say I square brackets name for I in products if I square brackets price is greater than 100. Look how amazing this is. These are terrific. I just accomplished both of these lines of code. I got done on one line, okay? So this is fantastic. This is the reason why I use list comprehension so much, and they're just really easy to read. Again, they can't accomplish everything, but they can do a lot for us. So let's go ahead and run this. And why don't we print new products? Okay, and you can see we get pear and kiwi. Now, if I come into this file and I run this, you can see down here we get pear and kiwi. So again, two lines of code using map and filter, and we did it all in one line with a list comprehension. Okay, so that will wrap up this lesson, and I will see you in the next one. Hello everybody, I hope you're ready for the next lesson because we are going to go over file handling. Now we're not going to go too in depth, I just want to go over the basics with you because this is a beginner course, but file handling is exceptionally important in all of programming because it allows us to work with external files and the data that's in external files. Now Python is the language of data science, so we work with a large amount of data, okay? And sometimes these data sets are huge. We couldn't store them in memory. And file handling in Python is really useful because we can actually break that data into smaller chunks, okay? Now, as usual, what we'll do is we'll right click, we'll create a file, and let's just call this file handling, okay? Now, there are two ways to work with files, but I don't want to show you one of the ways because it's improper, all right? So I want to show you how to work with a file using what's called a context manager. And to do that, we say with. Okay, we use the with keyword, and now we use the open function, all right? This function is going to create a file object for us. Now, what we would want to do is name the file here, and then we put a comma and we say what mode we want to open the file in. So I would just put, let's put read, okay? Now, there are three modes, okay? Three main modes. One would be write. And it's important that you understand these modes because if you write to a file, it will completely overwrite it. So you have to be very careful. Also, if you're trying to write a file and it doesn't exist, well, Python will see that and then it will create the file for you. Now, we're going to read from a file that we have, but just be aware that writing to a file will completely overwrite it. So how could you avoid that? You could append to a file. So we have read, write, and append. Append will add to the end of the file, okay? So it's a lot safer than writing to a file. There's also read plus, w plus, append plus. The only one I ever really use is read plus, but we're not going to get into that, okay? So read plus, by the way, would be read and write. Now, we've created our file object with this open function, and now we need to store it in a variable. And what we do is we say as f, okay? Now, you can name this anything you want. You could say file object. People say file obj. I just like to use f, okay? It's simple. And you're used to seeing us store variables to the left, okay? So it would be an equal sign. To the left of that equal sign would be the variable, and then we'd store this open function inside of it. But this context manager is just a little bit different. This is just the syntax. So this is our variable now, okay? And we use the as keyword. So while we're inside of the context manager, we're tabbed over, we are within context. And the file will remain open, okay? As soon as the context manager is done, or you're tabbed back into what's called global scope, which is back here, well, then the context manager will close that file for you. Now, why is that important? Well, if you just use the improper way, by just using the open function without the entire context manager, well, you can do that. But if you forget to close the file, you can run into a lot of issues, okay? You have to explicitly close the file. And that leaves developers, it leaves them open to making mistakes. We all make mistakes. You can have problems with file descriptors, leakage, and if you don't close a file, the data is still technically in transit. And data in transit is inherently less secure than data at rest. So again, just stick to using a context manager whenever you are doing file handling, okay? Now, let's just go over read, okay? Why don't we start off by discussing some of the ways we can read from a file. One of my favorite ways to read from a file is just simple. It's just f.read, okay? And then what we would do is store this in a variable. Okay, and then I can actually just print contents. So let's go ahead and run this. And you can see it's reading the file. Now, if I was to open the file down here, you can see it's reading it perfectly, okay? But perhaps I wanted to work with this data. Now, generally, each line will represent a new, like a new part of that data. So what you would want to do is read lines. So you could read lines, run it, and now you're storing each line, which represents a new piece of data, inside of a list. This is a little bit easier to work with a lot of times, okay? Now, I also like to do this, where I do f.read.split. And how do we want to split it? We want to split it by a new line. So now if I run this, you can see this is a little bit cleaner because it gets rid of that \n. All right? So let's go ahead and talk about specifying how many characters you want to read. Well, let's delete this .split method. And now what I can do is I can pass an argument in here, and I can specify how many characters I want to read. So let's just go ahead and read 15 and run this. And you can see it's only reading the first line. Let's go ahead and pass in 23. And now you can see it's reading 23 characters, okay? So you can specify how many characters you want to read. Again, this goes back to Python allowing us to break data down into smaller portions, okay? Now, of course, the file that we're working with is not very large, but we're going to pretend it's huge, and we're just breaking this down into small little portions, okay? So this is one way to do it. But another way to do it is also we can actually iterate right through our file object. So I would say for line in F, okay, and I would print the line. All right, let's go ahead and run this. And you can see this works perfect, okay? Now, one problem is this extra line. I wouldn't say it's a problem, but if it bothers you, what you can do is you can specify keyword argument, and you would end, instead of ending with a new line, you're going to end with an empty string. So if we run this now, you can see that kind of fixes it for us if you don't like that extra space being in there. Okay, now, like I said, if you write to a file, what will happen is it will end up writing over the entire file. So you have to be very careful. I quickly want to show you a pen, then we'll wrap up this lesson. I don't want to go too in depth. So let's go ahead and put an A here. Okay, now we're appending to the file. So what we want to do is delete this for loop, and we can just write to it, but it would write in append mode. So I would say f.write, and let's just go ahead and write, this is the fourth test. And let's go ahead and run this. Now, you can see it didn't overwrite the file, but it actually appended right to the last T. This isn't very desirable. So a lot of times you want this to come down here. So let's go ahead and fix that. Let's just say this is the fifth test. And what I would do is put a \n right here. Okay. Let's go ahead and run this. And then there you go. So that kind of fixes that little issue that we just saw where it added it right to the very end, basically concatenated it to the last character. So that's file handling. Feel free to explore it. Go on Google. There's a lot of information on file handling. Again, this is a beginner course, so I don't want to get too in depth, but I will see you guys in the next lesson. All right, bye. Hello, everybody. I hope you're ready for the next lesson because we are going to go over exception handling. Okay. Now, what is an exception? It is simply an event that occurs during the execution of our program that will disrupt the normal flow of our instructions. Okay. So when an exception occurs, it is being raised. What is an exception? Again, it's just an error. Okay. It's going to break our code. So as usual, let's go ahead and right click and let's create a new file and let's call this exception handling. Okay, so let's go ahead and create a program that is vulnerable to an exception. Okay, so I'm going to ask somebody for their age. And I'm going to set it equal to input, and I'm going to say, please enter your age. Okay, and because I'm asking for their age and I want to do some evaluation with it, what I'm going to do is I'm going to convert this or typecast it, okay? And we'll typecast it to an integer. Now, let's evaluate this age. We'll say, if age is greater than or equal to 21, we will print, you are legal to drink. Okay. And then we'll just go ahead and add an else block, and we can say, you are not legal to drink. All right. So I have this program, and on line 1, this is vulnerable to an exception, okay? And let's go ahead and run this so I can demonstrate. So I'll run this. I'm going to put in an age, but I'm going to make a mistake. For some reason, I'm just going to put in my name instead because I'm just doing other things. I'm distracted, and I'm running this program, and I just go ahead and put my age in, all right? You can see we end up with an error, okay? Or a value error to be specific. Now, how do we fix this? Well, generally what we want to do when we're handling an exception is we want to basically fail gracefully, okay? We don't want this to happen because users get panicked. They don't see what this is. This is a big deal to people, okay? It's a big deal to me, and I like to write a lot of code. So I don't like to see errors. And what we want to do is handle that gracefully, and we can do that using the try keyword and the except keyword. We can also use else and finally, but we're not going to go over that, okay? Let's just go over try and except. So what I want to do is I know that this code is vulnerable to errors, so I'm going to put it inside of a try block. So basically, I want to try this code. Try this code. And if it raises an exception, well, we'll handle that in the except block, okay? So I would just go ahead and print, you did not enter a valid age. Okay, so what's going to happen is if I cause an error in here, well, what'll happen is this except block will trigger, and then it's going to print, you did not enter a valid age. However, if this block of code runs, well, that's perfect. That's all we needed to do anyways, and everything will run just as normal. So let's go ahead and run this program now. And I'm just going to go ahead and put Dave, okay? And you can see the program handled the exception gracefully. Now, perhaps we wanted to loop this code so that no matter what, if they did not enter a valid age, we could just keep looping through the code, okay? And giving them another chance to enter a valid age. I could just simply put this in a while loop. So I would say while true. Now, again, be careful with while true loops. They're better than using flags, but a lot of times you just want to try to figure out if there's a condition that can be met. In this case, I'm just not seeing a condition that could be met. Maybe there is. I don't want to spend too much time. So what I'm going to do is use while true. Now, if this block of code works, what I'm going to do is break. Otherwise, the except block is going to run, you did not enter a valid age, and then it's actually going to run the while loop again, okay? So let's go ahead and run this. And I'm just going to put 21 here, okay? You're illegal to drink. Everything worked fine. The program exited. Now, if I run this again and I put Dave, you can see you did not enter a valid age. And then because we're in the while loop, it's allowing me to have another go at it. Okay. Now, there's something right here on line 9 that you may have noticed, and that's that yellow squiggly. And this is telling us we have a styling issue, and it's because we're using a bare except. What is a bare except? It's an exception that doesn't define or handle an exact exception that you want, or that's been caused. So let me demonstrate that if that doesn't make sense. Now, this is too broad. We're just handling any exception. But many times we want to say handle exception as E. Now, this is still a bit broad. This is still going to handle every exception, and it's going to print this error, but it's also going to store the error inside of this variable. So I could print that variable out too. So I could say you did not enter a valid age, and then I could put like a \n here, and I could say, what do I want to write? I'm doing an F string. Let's put a \n in here. Sorry. And then I'll say error. And then I'll put E in here, okay? And let's just go ahead and run this and see what we get now. So we'll stop and rerun. Okay. And let's just go ahead and put Dave here. And you can see now we're handling this exception a little bit better, okay? We're catching any exception, and what we're doing is we're storing the error code inside of this variable again. This is just how, this is proper styling, okay? Just having a bare except is not good enough. It just isn't. Now, the best way to do this is to actually put the exception that you know will occur. And we know that only one error can occur here, and that's going to be a value error. So I would say accept value error as E. Now, this is a little bit more readable. For example, if someone else is working on my code, they may come into this except block and see that a value error can occur, okay? And that might just give them a little bit more insight into what's going on with my program, and it allows them to work with my code a little bit better, okay? It just gives us more information. It's better to do an except block like this. Now, we can also use an else and a finally block. Again, we're not going to get into that. This is good enough for now because this, like I said, this is a beginner course, okay? Now, that will wrap up the end of the lesson, but just a quick recap. When we don't know if something's going to cause an error or we know it's going to cause an error, we can put it inside of a try block, okay? If the error occurs, it was raised, and the except block runs. It's that simple. Okay, I will see you in the next lesson. Bye. Hello everybody, I hope you're ready for the next lesson. This is the last lesson, and we are going to be going over object-oriented programming. Now, we're not going to go too deep into it because, again, this is a beginner course, but why don't we go ahead and start? So, let's go ahead and, first off, create a file. So, we're going to call this OOP, okay? Now, let's quickly talk about object-oriented programming, okay? Object-oriented programming is a programming paradigm. It's a way of organizing and writing your code, and it's based off of the idea of objects, okay? And objects are collections of data and like functionality that represent real-world things, okay? So I may have an object in Python that represents an actual car in the real world. I mean, I can represent pretty much anything you can think of, okay? Now, objects are made from classes, okay? Classes are blueprints for creating objects, okay? We only build one class, and then we can build as many objects from that class as we want, okay? This class will define the attributes and the behaviors that the objects are going to have, okay? So if I had a dog class, well, I can create a bunch of different dogs from that class, okay? And they're all going to have the same attributes and behaviors, but they're not going to have the same attribute values, okay? So I think it's best for us to just start coding, okay, instead of talking about it. So let's go ahead and first off, create a class, okay? So to do that, we're going to use the class keyword. So we'll say class, okay? And what I want to do is I want to create a class for cars, all right? So I'm going to call this class car. And it's proper convention to use an uppercase, okay? Now, we'll put our colon, And the first thing that we generally want to do is create an initializer or a constructor, okay? So to do that, we're going to say def underscore underscore init right here, okay? And this is where we're going to pass in our attributes, okay? User-defined attribute values, basically. And to do that, what we'll do is we'll come up here. I want you to ignore this keyword, this word self for now, okay? So let's go ahead and put a comma. And we know that every car is going to have a make and a model, okay? And now what we want to do is kind of set their variables. So we do that by saying self.make equals make, okay? And self.model equals model. Okay, so we have now created an initializer method, okay? This is going to run automatically when you create an object, okay? Now, what we want to do is define some behaviors of a car. Some behaviors might be def drive, okay? In this car, we'll just go ahead and we'll print, I don't know, we'll print the car, geez, I can't spell today, is driving. Okay. All right. So we have this one behavior. Okay. What are behaviors that are inside of a class? Those are called methods. All right. And now we'll create one more. We'll call it def stop. So every car drives and every car stops, hopefully. And let's go ahead and print the car is stopping. Okay. So we have successfully created a class, and I can create as many car objects as I want from this class. And to do that, what we do is we do what's called instantiating an instance, okay? An instance is an object of a class. So I'm going to do that by just saying, I'm going to name my instance. I'm just going to call it C1. You can name it whatever you want, but it should be meaningful. And then I'm going to say it equals a car, okay? And now I want to put parentheses because this car class requires that I put in the make and the model, all right? So I'm going to go ahead and say, let's not do a Tesla. Let's do a Ford, and we'll do an F-150, okay? So I have now instantiated an instance, or I have created an object of the car class. Let's talk about self. What is self? Self is a reference to the object itself, okay? And this is how we're able to create as many as we want, actually, usually an arbitrary amount of objects based off of this class. So the instance name gets passed in first. So C1 literally gets passed in first into this self, okay, this self parameter, all right? And now what's going to happen is we're saying C1.make equals Ford and C1.model equals F-150. And that, again, helps me differentiate between all of my objects, all right? If I didn't have this self parameter, nothing would work. It wouldn't know which object we're talking about or which instance we're talking about. Okay, so now I have this car instance, and what I can do is I can access all of the car methods by typing C1 and then using the dot operator, just like we do with strings or integers or lists or dictionaries. It doesn't matter. We use the dot object to access the methods. Now you can see we have two methods here. We have drive and we have stop, okay? So let's just go ahead and call the drive method. And we're going to see the car is driving. Now let's make this a little bit more unique, okay? So I'm going to make this an F string, and I want to put the actual make and model of the car. So I want to say self.make. Let's put the. We'll say the self.make self.model is driving. Okay, and let's go ahead and run this now. And you can see, because it's passing in C1 first, which is self, we know C1.make is equal to Ford and C1.model is equal to F-150. That's going to get passed in because we're directly working with this instance, okay? So again, that's how we can organize having multiple instances of a class. Let's go ahead and create a C2 just so you can see a little bit better how it differentiates between the two. And let's just go ahead and put a Dodge, and we'll do a Dodge Ram, okay? Now, if I call C2.drive, what's going to happen? Remember, we're working with C2 now, so C2 gets passed in, and we know that we have C2.make equals Dodge and C2.model equals RAM. So when I call this drive method, C2.make, which is Dodge, and then RAM is going to get passed in. So let's go ahead and run this, and you can see the Dodge RAM is driving. So again, self just it refers to the instance, all right? Okay, so that's just a quick way to create a class. Again, we're not going to get too in depth here because it's a beginner course. But what I want to do now is just show you inheritance, okay? So what I'm going to do is I'm going to delete these. Actually, I'll comment them out. And I want to create another class, but it's only for electric cars, okay? And I want you to pretend that this class is huge. There's a lot going on inside this init model. Now, I could create my own class for electric cars and start from scratch and just build it out just like a regular car. Or I can use inheritance, okay? Which may be much more useful because it's going to save me a lot of code. Again, pretend that this car class is very complex, okay? And this init method may be initializing some kind of a database or just anything. Just pretend it's more complex. And we don't want to write a complete class from scratch. What we can do is use inheritance. So I would say class electric car, and then I use the parentheses and I inherit from car, okay? Now, if I create my initializer method, it's going to look a little bit different because not only do I want to initialize the attributes for the electric car, I want to initialize this init method of the parent, okay? So what I would do is put an init here, and we still have to have the same attributes, okay? So we define the same attributes, and we would say make model, and let's just do battery size. So we'll say B size, okay? Because that's going to be the major difference between, say, a car and an electric car, all right? Now, what we want to do is call the initializer method of the parent. So we use super to do that, okay? So we'll say super.init, okay? And now what we want to do is just pass in the parameters for that actual init method of the parent class, which is going to be make and model, okay? And now the only thing that we need to take care of is the battery size, okay? Now, again, this is important that we do this because there may be a lot going on in this parent's initializer method. It may be initializing a database or doing something that's complex that we don't want to rewrite, okay? So in our child init method, we call the parent's init method. And you still have to pass these in, okay? But what we don't have to do is we don't have to kind of store them in a variable like we did on line 3 and 4. All right, so now what I'm going to do is just take care of battery size. So I'm going to say self.bsize equals bsize, okay? So now I have successfully inherited from the parent class, okay? So let's go ahead and talk about like overriding methods. So basically the child has all the power when it comes to programming. The child's going to have all the power, okay? So whatever, I can access the parent and all of its methods with the child, but I can't do it the other way around, okay? I can't take a parent object and access all of these child attributes and methods. It's just not possible, okay? So if we were to create the same method, well, what would happen is it would overwrite it. But first off, let's go ahead and create an electric car, okay? So we're going to say electric car 1 equals electric car. And this one needs a make, model, and a battery size. So we'll say Tesla. We'll do a plaid. And let's make the size like just 300, okay? Some random integer. All right, and that's too many blank lines. Okay, so we have this electric car. And if I was to say EC1 and I use the dot operator, you can see I have access to the parent's methods, okay? But also, if I create the method here, so I would say def drive, and down here I would say print, what do we want to do? We'll say the electric car has a, let's do something like this. Self dot make we'll do self dot, I can't spell today. Okay. Self dot model is driving on its, I don't know, we'll say self.bsize. Is driving on its self.bsize battery. We'll do something like that. Okay, kind of random. Doesn't totally make sense, but, you know, it'll work. So now if I come down here and I try to access that drive method again, well, it's not going to grab the parents, okay? And you can see over here to the right, because we overrode it, okay? The child takes precedence. So it's no longer going to access the parents drive method. It's only going to access its own drive method, okay? So if I say drive and run this, you can see the Tesla Plaid is driving on its 300 battery. Okay, so that's just like the basics of inheritance. Again, it's just to allow for better reusability, okay? And like I said, there could be a lot going on inside of a car class initializer that you just really, you really want to use all of that code. Why would you start over from scratch and start writing all of this code when you can just simply inherit and then use this super method to call the parent's initializer? Okay, so let's go ahead and move on. We're going to just use two objects together, okay? So what I'm going to do is I'm going to grab all of this, and I'm going to comment everything except car out. In fact, I'm going to comment everything out. And now what I want to do is I want to create a car, and I want to create a garage, okay? And what I want to do, I will say class garage, so class garage. And what I want to do up here is give every car a horsepower, okay? So we'll say HP, and we'll say self.hp equals HP. So self.hp equals HP. And that's going to represent horsepower. So now when you create a car, you have to put the make, the model, and the horsepower. And for garage, what we're going to do is we're going to create an initializer. And I want to just give it two attributes. So we'll say def init. I want to give it a max. We'll do a max size. And then we'll do, I think all we need is a max size. Yeah, we'll just do a max size. Okay, that's going to be the only user-defined attribute. But there's going to be another attribute that we're going to write. It's not going to be user-defined. So I'm going to say self.max size equals max size, and then I'm going to say self dot garage space equals an empty list. This is going to represent the space that's in a garage, okay? If we can park cars inside of a garage, I need to be able to represent that space. And one of the best ways to do that is by using a list, okay? So every time I create a garage object, it's going to have a user-defined max size, but it's going to have a non-user-defined list that represents the space inside of that garage. And now I'll be able to put car objects that I create inside of this garage, okay? So let's go ahead and create a method to allow us to insert a car object inside of this garage, okay? So I'm going to say def, let's say add car. And we have to put a parameter here that's going to represent the car. So I'm just going to say car. And what I'm going to do is say if the len of self.garage space, if the length is less than self.max size, we know the garage is not full, and therefore we will be able to add a car to it, okay? So what I'll say is self.garage dot append, right? That's how we add to a list. Remember, self.garage space represents a list. And what are we going to append? The car that they put in, okay? Now, if it's full, why don't we just print a message, okay? So we'll just say else print the garage is full. Okay. And now what I want to do is I want to create a behavior. Okay. And this behavior is going to go through each car, and it's going to give us the average amount of horsepower that's in our garage. So if I have a Lambo and I have a Corvette, a Porsche, and a Bugatti, it's going to get the average of all of the horsepower that's inside of that garage, okay? And to do that, what we can do is create the method to do it. So what we would say is def AVG, let's say HP, okay? So average horsepower, okay? And what it's going to do is we basically need to iterate through this list, okay? So we're going to start with a value. We're going to set that equal to 0. And then we're going to iterate through our garage space. It's a list, right? It represents the space, and there's cars inside of that list. So I would say for car in self.garage space, value plus equals car.hp, okay? Car.hp. So every single car has an attribute called HP. And that's going to be, maybe like a 500 or a 300. So it's going to be an integer. And what we're going to do is we're going to add that to the value, okay? So now that I have the value and I'm adding the car HP to each one, this for loop has done its job. So what we can do is we can return the, why don't we do the value divided by the len of self.garage space. Okay, and this should give us the average horsepower. Okay, so let's go ahead and let's get rid of everything down here because I want to, or we'll create more space. We'll create more space. So again, we want to create an instance or instantiate an instance of both classes. Okay, so the first thing, let's just go ahead and create a garage first. Okay, so I'm going to say garage1 equals garage. Okay, and now I want to just pass in one attribute, which is going to be the garage size. So there's going to be a max of 4 cars. Okay, now I have a garage and I need to create some car objects. So I'm going to say C1 equals car, and we'll do all like exotic. So we'll do Lambo, and the Lambo will have a Aventador, and let's give it a horsepower of like, I think it's like 900 or something like that. Okay, and I'm going to hit Control D. Okay, and I'm going to do C2. I'm going to call this a Porsche. We'll just give it a, we'll say it's a 911. We'll do C3. We'll do a Bugatti for C3. This person's got a nice garage. Bugatti. We'll do the Chiron. I think it's got over 1,000 horsepower, so I'm just going to put like 1,100 here. And then one of my favorite cars, we'll just put a classic in here. So we'll say, let me just Control D this. We'll say McLaren F1, which I think had like 700 horsepower. Okay. So I have a garage that can hold 4 cars, and I've created 4 car objects. Now I want to add these cars to the garage, okay? So what I would do is I would say G1 dot add car. And I have these car objects, so I'm just going to go ahead and add C1. And because of the way I wrote this method, okay, I'm going to have to do one at a time. Now, you could rebuild this so that it takes all 4 objects at once, but just for the purpose of this lesson, we'll stick with this. And I'm just going to hit Control D, 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 and I'm going to say C2, C3, C4. Okay, so I've created the garage, I created the 4 car objects, and I added each car to the garage. Now that's the max. If I was to try to add another car, it's just not going to work, okay? And it's going to print a message. It's going to say the garage is full, all right? And now what we want to do is we want to get the average horsepower, okay? So let's go ahead and print G1 dot average horsepower. And let's go ahead and run this. And you can see the average horsepower is 900, okay? So this is how we use two objects together, all right? Now, I don't want to go any further than this. Again, it's a beginner course. I know I reiterate that all the time, but I hope that you've enjoyed it. That's going to wrap up this lesson, okay? So we went over just creating a class, using inheritance, and then using two objects together. And what I would recommend doing is either going on Google, and you can learn a lot more on Google, obviously. But also, I wanted to let you know that I am coming out with a more advanced Python course. It's not done yet, but as soon as it is, I will make sure that I put a link to it in the description of this video, okay? So thanks so much. I hope that you guys learned a lot. I hope that it was easy and I broke it down in layman's terms for you, and I hope you get a better understanding of Python from this course. And thank you so much. Goodbye.